Hi everyone.
Good morning, sir. Shall we start the session, sir? Gaurav, sir, am I audible to you?
Yes, I can hear you.
Okay. Good morning to all the dignitaries, faculty members, and dear participants. I, Priyanka Saxena, welcomes you all in third day of 1 week online AICTE ATAL FDP on IoT and its applications. Today, we have with us Mr. Gaurav Kanungo. He is currently working as a technical lead at IBM. He has done his MTech from SATI Vidisha and B from RGPV. He is an accomplished software developer with experience in multiple roles of software design and development process. He's interested in research and design and development involving new innovative technologies. He has a 15 years of experience in analysis, design, development, and customization of software applications. Prior to IBM, he has worked with NIIT Technologies, ST Softech, India, and CoreCard Software. He has been honored with several awards like Service Excellence Award by IBM Global Business Services, Award of Excellence by NIIT Technologies Limited, Eminence in Excellence Award by IBM, Innovation and Delivery Excellence Award by IBM, GIC On-Site Talent Award by IBM. Sir, on behalf of SoIT, I would like to welcome you and thank you so much for accepting our invitation.
Thanks, Priyanka. And thanks for so many. I think it is a bit exaggerated, but thanks for introduction. And I think
I have made you the co-host. Now you have the rights to share the screen as well.
Okay, sure. So let me share the screen. I have created a presentation in PowerPoint, so I will share that and then we will talk about it.
Yeah, sure.
So, okay.
Yes, sir, it is visible.
So, okay. So for today's session, what I have outlined is just an overview of Raspberry Pi and what is it and how it functions, what are the different models, then what are the specs, components, and what input output ports are available, what is the difference between Raspberry Pi and Arduino devices, what operating systems we can install on a Raspberry Pi, and there is another version of Debian based operating system which is called DITE-Pi, which is very like low resource consuming OS. So we will see how a DITE-Pi operating system can be set up on Raspberry Pi and how a headless setup can be done. Then we will briefly discuss how we can set up containers and clusters and swarms on Raspberry Pi using different technologies like Docker or Kubernetes, and what options we have to set up these things on Raspberry Pi. Next, we'll come to Python and what are the different ways to set up Python environments for development or for production usage, also how we can set up these environments, and because Python programs have multiple dependencies which are like runtime libraries and other stuff, so how those dependencies can be easily managed using different tools. So we will talk about it also. Then we will briefly see what is MicroPython and how it functions, and we will not go into much detail because right now I do not have any setup of MicroPython or a device which can run it. but we will discuss what is MicroPython because it is more related to the IoT devices, which is the topic of this discussion. And we will just briefly go through some of the IoT projects based on Raspberry Pi. And in the last, we will discuss my personal project that I have recently set up in my home network, which is a DNS based ad blocker. It is not very like specific to Python programming, but it is a use case of Raspberry Pi, and we will see how it functions and what benefits we get if we set up such ad blocker in a home network. So these are the topics that we are going to discuss today, and I will move to the next slide. Okay, so what is Raspberry Pi? We all know that it is a single board based computer, which we call SBC also. It is developed by Raspberry Pi Foundation, which is a UK based charity organization. And originally it was designed to provide young people with an affordable computing option to learn how to program. And subsequently, it has developed a massive following in the market and do-it-yourself communities because of its compact size, multiple input-output options, ability to install full Linux environments, and ability to interact with other devices using the general purpose input-output pins that all the Raspberry Pi devices have. So we will move ahead, and on the next slide, we will discuss some of the models of Raspberry Pi which are in market and what options we have if we want to get Raspberry Pi in our like for hands-on experience. So this particular screen is showing Raspberry Pi 4. It is one of the recent model, not the latest one, because we have some of the subsequent models after this also. And in this sorry. Okay, so in this Raspberry Pi 4 model, we have choice of RAM. So we can get a 2 GB model, we can get a 4 GB or 8 GB model. We have a more powerful processor. It uses a USB-C power supply instead of the earlier micro USB port. This time it has two HDMI ports, so you can connect two displays or two monitors simultaneously with 4K display support. It has USB 2 ports, two USB 2 ports and two USB 3 ports, and 1 gigabit Ethernet adapter. So unlike earlier models which did not have the gigabit Ethernet or USB 3 ports, so they were a bit slow in input output because the total bandwidth was limited. But this model has overcome these limitations and supports more bandwidth, and due to that we can use this particular Raspberry Pi 4 device in like use cases like network attached storage also, because you can just plug in any USB 3 external disk and install the required software, and this Pi can function as a network attached storage. So we will come to that part also, how it can be done, but we will see other models that we have for Raspberry Pi. So I'm coming to the next slide. This is an interesting model, and it does not has all the ports that we have seen in our previous slide, but there is an interesting case with this particular model. It is called Raspberry Pi Compute Module 4, and the thing is, it is not a complete Raspberry Pi device in itself. Instead of it, it has some of the components of Raspberry Pi, like its microprocessor, RAM, and for input output, it has that chip. But it requires a carrier board for the input output. So there are nowadays there are multiple manufacturers are making different kind of carrier boards for compute module 4 to attach this compute module 4 or to deploy this compute module 4 onto those carrier boards and then use it as required, like for different use cases it can be used. So I generally follow one interesting website. I'll come to that just a minute. It is actually a blog of Jeff Gerling, and he reviews multiple carrier boards. And for example, using this compute module 4, we can set up our own router. We can set up different kind of network attached storage. We can set up home automation systems, and we can set up Docker based clusters or Kubernetes based clusters. So it has multiple usage, and the processor and RAM configurations are similar to compute module 4 that we have seen earlier. But it can also support NVMe 2 drives. So the SSD drives that we use nowadays in modern systems, because it has a lot more bandwidth than the USB interface. So it is a PCI Express based device, and this compute module 4 supports PCI Express based devices. So we can install NVMe modules and such SSD devices directly into the Raspberry Pi with compute module 4 configuration. I'll come to the next slide. This is released most recently, Raspberry Pi 02W, and it is basically a scaled down version of Raspberry Pi, and it has a newer processor than Raspberry Pi 0 model that was released a few years back. It has a 512 MB of memory, and it is very cheap. It comes in, I think it is $15 only, and it has various usage. It supports SD card, it supports input output ports also, and for example, we can install entire operating system also on this particular device, but it is not as powerful as Raspberry Pi 4 or compute module 4, but it is a cheap device. So its use cases are different. Like for example, if you want to use it as a IoT device or as a hub for your, nowadays we have this a common practice of Wi-Fi based bulbs are light bulbs are common. So we can manage those light bulbs or electronic devices using this particular model, and it is very cheap. So I'll come to the next one. Yeah. So this is Raspberry Pi 3 model B. After that, we had one B plus also, but I am showing this one because currently in my setup, I have this device only. So we will talk about it. We will see what operating system can be installed on this device and how it can work. So this is the device which has about 1 GB of RAM, and it has 1.2 gigahertz of clock speed, and it has one HDMI port, 100 Mbps Ethernet port, 4 USB 2 ports. It does not have USB 3, and one micro USB port for power input. So, and other than that, it has some camera interface ports and GPIO pins. So that's how it works. And GPIO configuration is same as what we have in Raspberry Pi 4 model. So we'll talk about it also, and we will have some hands-on experience on this device because I have currently this running in my system, in my home network. So we will learn more about it. Okay, so most of the Raspberry Pi models have different components, but some are common and some are different. So here in this slide, we are particularly talking about Raspberry Pi 4 model and what input output components it has. So I think we have already discussed, but I will just briefly go through it. So GPIO pins are 40 pins that are available. These pins can be used to connect to Raspberry Pi to other electronic components, and it could be IoT devices as well. It could be we can use it for robotics, and it is actually general purpose input output. So any electronic component can interface with this pin configuration. Second is Ethernet port. So this Ethernet port connects Raspberry Pi to a wired network. The Raspberry Pi also has a Wi-Fi and Bluetooth built in for wireless connection. So for network connection, we can just have our Raspberry Pi placed anywhere in the home or anywhere in our lab or office and connect to the Wi-Fi. It does not need any physical or wired connection, but for a better performance, if our use case requires a consistent network connection, then we can use the Ethernet port also. And Raspberry Pi 4 has 1 Gbps port, and Raspberry Pi 3 has a 100 Mbps Ethernet port. So currently I'm using this Ethernet port in my setup. There are different ways to use both the ports. Like at a time we can use Ethernet port and Wi-Fi port also, and we can discuss those things later on if required. The Model 4 has 2 USB 3 and 2 USB 2 ports. These USB ports are used to connect peripherals like keyboard, mouse, and other devices that we can connect is external hard disks. We can connect Wi-Fi adapters if we need more Wi-Fi ability, or any other USB device that we want to connect. For example, we want to connect some microphone, speakers, or any other device, we can connect using these ports. Even if you want to increase the number of ports, you can probably connect a USB hub to this, and it can support more devices. But we have to make sure that if we are connecting more devices, the Raspberry Pi power should be delivered separately using a powered hub. So in market, there are models available which have capability to deliver power, not using the Raspberry Pi, but using a separate adapter in the powered hub. So we can use that kind of powered hub to connect more devices than what is available in this model. Then there is an audio video jack to connect speakers or headphones, the analog method of connecting them. The camera module to connect the camera module. Camera module is available along with other components on Raspberry Pi website. So we can connect cameras also. We can use it for surveillance purpose as well. The next is HDMI port. As we all know, it used to connect monitors or any like it supports HDMI, supports audio video both. So we are not required to connect audio video jack if we are connecting through HDMI. Then there is a USB power port. It is for power input. It is now in Compute Module 4, it is type C. Earlier it was micro USB. Then there is a external display port for touch display purpose. And then there is a micro SD card slot. It is underside of the board, and it is used to boot Raspberry Pi from the operating system installed on this micro SD card slot. But interestingly, in our newer model in Raspberry Pi 4, it has capability to boot using a USB device also. So for example, if we want to install our operating system in a bootable USB disk and we want to use that, then we can do that with the USB disk, and we do not need any micro SD card in such a case. But there is some configuration changes required to do that, and I think it is not in the scope of this discussion, but yeah, definitely it is possible and we can do that. Okay, so any questions so far, or shall I move to the next slide? Okay, so I'm moving to the next slide, and here we are briefly touching upon one more topic, because Raspberry Pi is a general purpose Linux based computer which has a full operating system. It can have a GUI interface also, and it can run many different programs at the same time because it is more capable. It has not as powerful as a laptop or a desktop device, but still it is more powerful than a Arduino devices. So on the other hand, the Arduino is another device that is widely used in physical computing. While there is some overlap in the capabilities of Arduino and Raspberry Pi, there are some distinct differences. Arduino platform provides a hardware and software interface for programming microcontrollers. A microcontroller is an integrated circuit that allows you to read input and send output to electronic components. Arduino boards generally have limited memory, so they are often used to repeatedly run a single program that interacts with electronics. So here in this slide, what we see is Arduino devices are okay. Arduino devices are more IoT related stuff. They interact with like microcontrollers, and they can be programmed for specific use cases. Whereas Raspberry Pi is more like a general purpose system. It can have different usage. The software that supports or that can be installed on Raspberry Pi includes a web browser, MS Office, or a Linux based Office suite, a terminal, or even a Minecraft game can be installed on this. It also has Wi-Fi and Bluetooth capabilities for input output, and it can run Python and other. For Arduino devices, it is better to run a different version of Python, which we will see in our next slides, which is called MicroPython, and it is better suited for Arduino based or microcontroller based devices. A stark difference is Raspberry Pi can run full-fledged Python without any configuration changes, but that's not the case with Arduino. So we'll see that. Coming to the next slide. Okay. So now we will discuss what operating systems we can install on a Raspberry Pi and what systems are available. So there are like a vast list of operating systems supported. We will see some of them. We will discuss some of them. So the most popular operating system, which is provided by Raspberry Pi Foundation only, is Raspbian, and it is a Debian Linux-based OS. It has been customized especially for Raspberry Pi, and it can be used as a general purpose OS. So if you want to use Raspberry Pi as a desktop system or for any like general computing purpose, you can use it. For development purpose also, you can use Raspbian. But if you do not want to use Raspbian and you have some specific use case, for example, if you want to use your Raspberry Pi as a media center for your lab network or home network or work related stuff, you can set up this second operating system, which is called OSMC, Open Source Media Center. It is free, simple, open source, and easy to use standalone. It is a Kodi OS based operating system, and it actually used to play any media format over the network. So it can stream videos and different media formats over the network, and it is better suited for this purpose rather than a general purpose use. The third one that we will discuss is OpenELEC, Open Embedded Linux Entertainment Center. It is similar to OSMC, but it is more lightweight. It does not use that much resources, and it is more like performant than the OSMC, but the use is similar. The next one is an interesting operating system. It is RISC OS, is a unique open source OS designed specifically for ARM processors. So one interesting thing that we have not discussed so far is the microprocessor architecture of Raspberry Pi is ARM based, and the ARM architecture is because since Raspberry Pi version 3 and after that, it supports both 32-bit instruction set as well as 64-bit instruction sets. Therefore, we can run an operating system which is 64-bit also on a Raspberry Pi 3 or later models. In today's hands-on, we will see like actually I am running a 64-bit OS, so we will see that one. But Raspberry Pi as hardware supports both 32-bit and 64-bit OS, but both should be on ARM based architecture. And the one more thing that I wanted to bring to your notice is there are two different instruction set, like there were different specifications, and later on those specifications were merged, but currently we have ARM 64 and ARM 32, two different specifications that are supported by this hardware. And this RISC OS that we are discussing right now is for ARM processors. It was created for ARM processor. It is not Linux, it is not Windows, it is a separate operating system. And for any research purpose, or for students who want to learn how to design an operating system or more internals of an OS and things like that, it is a better choice to explore RISC OS further on a Raspberry Pi. The next one is another interesting variant of Windows, which can be installed on a Raspberry Pi device. It is called Windows IoT Core, and it is specifically designed for this purpose. Otherwise, we cannot install Windows on a Raspberry Pi, but this particular version can be installed, and it is aimed for programmers to use it to build prototypes of IoT devices and using Raspberry Pi and Windows 10. So it is Windows 10 based OS. But yeah, if we are using Windows IoT Core, so it is better to install it on Raspberry Pi 4 with at least 4 GB of RAM. And I have also included a link, and I will share this PPT with organizers to share it with the forum, so we can see more operating systems that are compatible or can be installed on Raspberry Pi using this link. The easy way to select the operating system install is basically a new out-of-the-box software that is available for download on the Raspberry Pi Foundation site. If we install this software, it actually asks us which OS we want to install, and we can just simply select that operating system name, and it can easily install that on the SD card that we are going to insert in the Raspberry Pi device. So that is how the operating system can be chosen using nodes. So that's it on this slide, and now I'll come to the next one. Okay, so now another interesting thing, and I want to show that actually on a actual system, but before we go there, we will just discuss what is this. So as Raspbian, DietPi is also an operating system based on Debian. So Raspbian is also based on Debian OS, which is a very popular distribution of Linux operating system for general computing. And DietPi is also based on Debian, but it is extremely lightweight, and even the GUI or graphical interface installation is optional in DITEPy. If we want to install, we can install. If we do not want, we have a different use case, we can choose to not install the GUI component. It is highly optimized for minimal CPU and RAM resource usage, and it ensures that your single board computer always runs at a maximum potential. So that is the specific feature of this DITEPy OS, and it is not only for Raspberry Pi, it is available for multiple SBC boards, and even we can install it on a VM or a virtual device also. So it has multiple distributions available. I will come to previous slide. Yeah. And there are different programs which are already packaged and we can easily install for our use case. So those applications are pre-configured, optimized in DITEPy. So we will learn that also, how that can be installed. There is a library of multiple applications which we can launch using DITEPy software command, and we can see what we want to install, what we do not want to install. We can run different services, and we can choose which service we want to run and which we do not want to run. And we can automatically update the entire OS also if there is a new version coming up, or if any application which is installed on this OS has got a new version, we can easily install that and update our operating system using this type update command. So we will learn about it shortly, and we will also see how a headless setup can be done. So before we go there, I would like to share my screen and show you how I have it installed on my network and how we can run it. So this is basically my command line, and instead of directly going into Raspberry Pi, I will show you how we can log in. So I use a text-based interface, and SSH is the command that I use to log in into my Raspberry Pi. And this is my user ID, and this is the device name, rpi3b.local. It is on my local network. It is directly connected to the home router, and using Ethernet code, it is connected there. So I can directly log in into this device. So when I issued this command, it said that the key that I have set up for this, I'm using it for first time using this name. So it is asking, do you want to confirm that it is your key? And when I said yes, it has connected me to the device, and now I'm inside the device. So if I see what is the name of the device, it is giving me the name, what programs are running. I can see that, how much CPU, how much swap space is being consumed, what is the load. So you can see that overall load is very minimal, and out of 1 GB of RAM, only about 160 MB is consumed. The swap space has 2 GB, only 520K is consumed, and is running multiple different things. So we will go into those details also, like what it is running and how those things are set up. But this is something that we can figure out easily, and I will show you some of the other stuff as well. So one interesting thing is this command. So basically it is telling me what devices, storage devices I have connected to this system. So there are 4 partitions available, and how they are mounted into the file system. So it is my root device. It has a size of 10.3 GB. Out of it, only 3.6 GB. Sorry, it has total size of 16 GB. Out of that, 3.6 GB is used and 10.3 is free. It is ext4 partition for Linux. Another is boot device. It is a FAT partition, vFAT partition, 126 MB. Out of that, 31 or about 32 MB is in use, rest is free. Then there is a USB device connected. It is a 64 GB device, and out of that device we have two partitions. So one partition is FAT partition, which is some operating system recovery partition, and another one is user data partition, which has the services that I'm running on this device. I create log files, and those log files are transferred daily into this user data partition. So that's why this is set up. And then I have some network attached storage also, which is connected to the Raspberry Pi device as well. So if we want to like transfer some of the media from one place to another, or if we want to play that media on Raspberry Pi, I can easily do that. And these are the network device name. This is the local name because it is mounted locally here, and it is the network path from where the data is coming or from where it is mounted. And then these are the special devices which are created by the operating system for different purpose. And we can see some are temporary file systems and some are device file systems. So it is a common technique in Linux to mount every device as in the file system using these mount points. So that is what we see here. And after that, we will just see those commands also that we have seen in earlier slide. So I will go to TypePy launcher. Yes, so I have to run this command as a super user. I cannot run as a normal user. So I'll go into that, give my password. And this is the launcher, which has all other options available. So if I want to install any new software or any additional software, I can easily do that without going to the command line. It has a menu for that, and there are different options available. So if we want to install a graphical user interface, there are different options available to install it. And this is not specific to TypePy operating system. It is available in Raspbian also and other OS that we have discussed earlier. So we can easily install these different desktop GUI into the Raspberry Pi OS. Then there are remote desktops. If we want to connect system remotely in a GUI interface, then we can use this software. There are different media systems. So if we are using our Raspberry Pi for not only for as a specific media center OS, but a general purpose, so we can install the media systems also. So it can be used to stream media over the network. If you have a smart TV and you want to connect to Raspberry Pi to play some videos or any media, then you can easily do that using these streaming services. It has Plex media interface, media service has a very good interface. Code is also good, and we can install this software to make this Raspberry Pi device a media center. Then if you want to like download torrents, then there are software for that. Different clients are available, and you can use as a Raspberry Pi as a download machine. So you can just issue your download command. For example, many operating systems are also available as a BitTorrent images, which uses a distributed technology to push the software across internet. So these software can be used easily to download. If you want to, there's interesting YouTube DL. It is Python based script, and it is very interesting because if you want to download any video from YouTube, and generally any web browser or any other software does not allow that, you have to install some specific add-on which come with a lot of crapware. So If you don't want to go through all that hassle, you can just use this Python based script YouTube DL, and you can easily install you can easily download the video from YouTube. Any video from YouTube can be easily downloaded using this script. If you want to set up your own cloud, then this is the software. If you want, this is named as on cloud. You can synchronize files across your multiple devices. You can share with others, and you can use it as a collaboration platform also. This is very interesting thing. It is a personal Git server. It has its own web interface, which is similar to GitHub. So if you want to host your own Git repositories, version control repository, you can use Box. It is Go based software. If you want to synchronize files across multiple systems, you can use this. So there are different utilities available for games and emulations. It is there for blog. There is WordPress. PHP is for bulletin board, forums. For communication, there is Matrix home server implementation as Synapse. And then this is for states and management. But now I'm coming to a more interesting thing, and we will go through our slides also again. But since we have these topics in the slide, so now I'm coming to the more interesting part, which is can we use containers and Kubernetes based swarms in the Raspberry Pi? So this is something that actually Raspberry Pi is very like low on resources. It has only 1 GB of RAM. So can we use these heavy duty software on this particular device? So yeah, that answer is yes. And there are some specific version available. For example, Kubernetes, if we install a full-fledged version of Kubernetes, then it will be very difficult, or it will be not performing very well. But there is a specific version of Kubernetes, which is called K3S, which is a distribution specifically designed or built for IoT and edge computing devices. And we can install that on this Raspberry Pi 3. Yeah, I even do not have a Raspberry Pi 4, which is the latest one. So on 3 also, we can install K3S, and we can even install Docker, Docker Compose, Docker Build also. One more interesting thing, if you have multiple IoT devices in your home and you want to create a dashboard of, for example, you want to see how much power your electronic devices are consuming, and if you want to monitor some like weather monitoring, or if you want to do some kind of sensors you have in your home, or you have some cameras for surveillance, then you can create a dashboard kind of interface using this Raspberry Pi. And there are different technologies available. One interesting technology which is used to monitor different computer systems is IPMI. We can use that, and we can do real-time monitoring of different devices. Similarly, for camera also, there are different devices available. So that kind of dashboard and website to monitor different things can be easily done. There are some hardware projects also available. So this is interesting library, because if we want to do interfacing with the GPIO pins on a Raspberry Pi, this particular library is specifically for that, and we can communicate with different devices using this Python library. There is another wiring Pi library, which is based on C programming language. If we want to draw different analytics and like graphs and charts, etc., then there is a software for that. So there are different software available. That's what I wanted to show here. For DNS server, for Pi-hole is that is what we are going to discuss next. But you will notice that I have not installed Pi-hole using this DietPy software. I will come to that point also, how I have installed it in this system. And you guys can go through these details if you install DietPy on a Raspberry Pi, and there are a lot of software and different programming languages are available for like Go, Python, and Java, Node. So a lot of programming languages are available. Nowadays, I am using Rust programming language, which is designed by Mozilla Foundation. It is very performant. The performance is comparable to C and C++. So that is also installed on this machine, not through the package manager, but separately using the command line. I installed that as well. And then there are different web browsers and graphical programs available. So it has a lot of options. Okay, so we can select and install software. But one thing that I wanted to share, that you will see it has a SSH server, and Dropbear is the server name. It is the software that I'm using. And currently my Raspberry Pi is in a different room where router is installed by the vendor, which connects me to the internet. And that router has an Ethernet port. That Ethernet port is connected to Raspberry Pi, and it is automatically assigning an IP address to the Raspberry Pi, and using that IP address I am using. But when I am connecting to Raspberry Pi, I do not have any monitor or keyboard attached to that. It is a headless system. There is no video or input device connected. I am just using the network interface to connect to this system, and I fully use this system using that network interface only. So for that kind of, and I am even not using any graphical UI, and that is because I don't want to use more resources on that system. So that's why I'm using SSH, and SSH is a secure shell server. So it uses encryption. It uses your public private key encryption decryption methods to let you log in into a remote system, and then you can work on that. So that's how we are connecting to this. And the interesting thing is that with a DietPy operating system, this SSH software or SSH server is automatically installed. So now we will go back to our slide, and we will see how we can set up a headless Raspberry Pi using DietPy. Okay, so for headless setup of DietPy, what we need is we have to download the OS image as similar to other operating systems. It is available on their websites, and this is the default login. Available, and it is the password. You can change it on your first login. And once we download the image, we have to write it into the SD card. If we are, most of the time we install it on a SD card only. So we write using software like Etcher or some other. So we install it on the flash card, and then the next step is we will insert the SD card into the device, and then turn the power on. And after that, we can keep it anywhere. If we have connected the like there is an option to connect to Wi-Fi also, but if that is not done, then the other option is you just put your network cable into the device, and then when you SSH into the device, it will directly connect you to the Raspberry Pi, and you can use the login and password to connect to that, and you will go to the shell, and you can even get the root access easily. So it is very easy. All the software is pre-installed, and you are not required to do anything there. So that's how a setup can be done. And next thing is basically yeah. So if you have a keyboard and monitor connected to your system, you can log in via console. If you do not have a keyboard or monitor connected, you can use it as a headless system without keyboard and monitor. You can use a SSH client like Putty or SSH command line To connect from a remote system, the assisted server dropbear is installed and enabled by default on that one. There is one more way that SPC is alternatively allowed to connect is a serial console via UART chip, which is by default enabled on that one. So this operating system has this serial console method also, which you can connect via USB port. So these are different connectivity options available for a headless setup as well. Next, we will discuss what options we have to install containers on Raspberry Pi. So give me 1 minute. I will take this break of a minute and then I'll come back. Okay, sorry for the interruption. So first we will see what are containers and why it is important to to have the ability to run the containers on Raspberry Pi, and what are the use cases that we have. So basically you all are already into software and use software like different programming software created in different programming languages, created for different operating systems, different like most of the software have different dependencies, and it is very difficult to like manage those dependencies and keep everything packaged for different configurations of operating system. And then when you install that software, it should run in the desired way on that target OS. So all these things are there, and since last few years we are seeing that there is a new buzzword in the industry which is called containerization, and we can run containers very easily, and that format is very common. So the interesting thing that we are going to see today is we can run these containers on Raspberry Pi also. So how is that possible? What are the limitations, and what we can do for that? So basically container is just a kind of in very simple words, we have seen virtual machines. Virtual machine is a kind of virtualization technology where the entire operating system has to be installed, and that runs on top of a host operating system. And we can run multiple VMs on top of a host operating system. But it is very heavy because it requires the entire operating system layer. And then on top of that, you can run any other software. So it gives you the similar, you can compartmentalize the different applications in VM, but it is not giving you the ability to run applications virtually. Like on a VM, if you are running multiple applications, they are running on the same OS. They are not compartmentalized into different memory space or OS space for that purpose. Containers are like little different. We can say they are like lightweight VMs, and they run on a host OS, but they do not need the entire OS layer to be running. So that is the interesting part, because they are they can run on a very minimal resources, and their file system is also very interesting because they store the required software in layers. So if you already have one layer, or if one layer is as a part of different container also it is available in your system, and you are not required to download it again. That layer will be available, and on top of that, if a different file system layer is needed, then only that will be downloaded, and it is very efficient in storage also. But the other interesting part of a container is you can actually include other components that your application requires, for example, libraries, services, or tools that you need to run your application. You can combine everything into a single container. You can package everything together, and then you can run that container on multiple machines also. So for example, if we see that if we are running a service like Twitter, and Twitter have thousands of servers across the globe, so how it can be updated? What is the easiest way to deploy new version of software across the globe? So in such scenarios where the distributed computing is more common and it is required to deploy easily, and the same thing should be running on across the systems, so containers play important role there. They are easy to manage. A single image can be distributed easily, and there are different distribution or deployment technologies also available, which can use protocols like BitTorrent to distribute binary images across the network. Can deploy it on thousands of servers. If anyone is interested, they can probably Google Twitter. Actually, many years back, Twitter has devised a method to deploy binary images across a large number of servers, and the protocol that they have developed is called Murder, MURDER, and that protocol is nowadays they have improved it a lot, and it is not being used in the exact same way, but it is interesting protocol, and it is very, it makes very easy to install some software across a large number of systems. So that is one thing very interesting. But since we are discussing containers, so containers also gives us ability to easily package everything together and deploy it across the systems. So there are like we can think of shipping container like a application container also. They are a standard size, so they can be moved around and port and shipped via sea or land. They can also contain almost anything. Docker containers can hold your software's code and its dependencies, so that it can easily run on many different machines. Developers often use them to create web application servers that run on their own machine for development, and then it is pushed to the cloud for production use or to be used by different. So how we can install a container on a Raspberry Pi? So on a SBC like Raspberry Pi 3 or later, the command is very easy. You have to just run this command. It will download the script and run that script that will install Docker client on your Raspberry Pi. So since I have already installed it, so we will see how it is running on that system. And once Docker is installed, we can create our own container or download pre-built containers from container registries also, and we can easily use that. So we will, I have already downloaded 2 containers, and we will see those containers, and we will, after that, we will come to the next slide. So I'm coming back to my system, and I will show how can we run a Python programming language on Raspberry Pi using a Docker container. So I'm coming to that slide. Give me a minute. Okay. So this is my Raspberry Pi. Again, I am going back to my OS shell. Okay. Okay. So now I am on the command prompt. Okay. I'm not running in root mode. So I am a normal user on this. And now I will run the command docker and I will run ps. So ps command gives me details of all the running containers, and it is showing me that a pi-hole container is currently running. Now I will issue another command, docker images. So I see that there are two images available in my system. One is pi-hole and another is Python. We will come to Python, but before that, we can do one more thing. I'll show you how we can run a new container, a very simple container, which is called hello world. So I'll just issue this command, docker run hello world. And I do not have this hello world image right now, but when I issue this command, it will download that image from the container registry, and then it will run that image. So when it ran that image, it printed simple hello from docker, and it was running inside the container. And then it will give other instructions and then exit. If I want to run Ubuntu on the Raspberry Pi, I have to run this command, and it will run Ubuntu. And if it will give me, like it will take me to the bash, which is the shell used by Ubuntu. So I will go into that shell. Right now we are not doing that, but I will similarly run Python. So what command I have to do for issue for that? Docker run -it. IT we are giving for interactive mode because we do not want to run that command in the background. We want to run it on the shell. So that's why. And Python. So Python is our container name that we have already seen earlier. Okay. So now I am inside Python, and this Python is version 3.1.10.0, which is the latest release version, and I can use it as I want into this shell. So for example, some simple mathematics we want to do. So it can easily do that. We can even design our own programs and do a lot of stuff on this REPL shell. And if you do not want that, we want to run our program, we can do that also. So it is very easy to do inside a container, and it will not consume much resources. It is simple, and the interface or the architecture of this particular container image is again ARM64 or AAR64 architecture. So Python is available in that architecture, so that image can be downloaded and can be executed. So we are not going into much detail into it, but we will see what options we have or what other things we have. So now this container I have just interrupted and came out of the container. So I am moved back to the shell, and now I am running docker ps command. So now I see again that my one container that was running earlier is now running, but the other Python container is not running. But now I will issue Python ps-a command, and I will see these two containers which are not running currently were available earlier. So the image is available. If we want to connect to that again, or if we want to run that container again, we can easily run it again. So everything, all the dependencies, all the libraries of Python are all available within this container, and we can see that also. So if we go to command docker images, we will see that the size of this Python container is 864 MB, which is like about close to 1 GB, and it has all the libraries. But the interesting thing is, if we want to remove that entire Python programming language from this system, you have to issue just simple command docker rmi and then Python. So it will remove everything in a single command. And If you want to install it again, we can again issue command docker run that we have issued earlier. It will download the same image again and it will run. Like those images are binary identical. There will be nothing different, but uh, actually I can give some background. For example, you all I think must be using Windows operating system, and we see that when we install too many applications on Windows, it becomes slow. The registry size increases, lot of registry keys are created, lot of files are created across the system drive, and then after a few years we go and install the operating system again to make it lean and clean. But with containers, this is not needed, and everything is portable. So if we remove it, everything related to that container is removed. No traces, no history, no configuration changes. Everything is removed, everything is portable, and then we can come back again and start fresh. So that is the interesting part. Other than that, what other things we can do? So we can probably search some of the interesting stuff. There is a docker search command available, and if I want to just run Linux, there are different versions of Linux. If I want to run Ubuntu, I can just docker run Ubuntu. I can issue this command. If I do not want to run Ubuntu, there is a very lightweight Linux distribution available, which is called Alpine. I can run it. So first I will pull the image. I just want to show like we can how easy to download a entire Linux distribution using containers. So the entire OS image is about 2.7 MB. It is downloaded. It is its hash value SHA-256 value of that image is written. We can verify it also if we want, but most often it is not needed. And now we can run this. So we can run a separate Linux distribution inside our Raspberry Pi using containers. So this is the command. It does not have a bash shell by default. It has sh shell. I'm using that. And now I'm inside the Alpine OS. So if I issue this command, I will see that I'm inside that container. If I see the host name, I will see this name. And if I come out of container, I will see a different name. This is the file system. It is different than my file system available on the host machine. So we can even do that also. We can have two separate sessions running, and we can compare, or we can exit from this, and then we can see this is a different file system. This is a different. So everything is portable and can be easily mounted and used. And whatever we do inside a container remains there. It does not come out of that container. But there are different things. So for example, if we are running an application server or a web server inside a container, how can that software interact with the network? So for that, what we can do is we can map our ports within the container to outside. So I will show an example of that, and then we will come back to next topic. So docker ps command we have seen earlier. Okay, so we will just go about little detail, and we see the container ID, which is automatically generated, which uniquely identifies that container. We see the image from where it is downloaded. So it is from the Pi-hole repository, and Pi-hole is the image name. And then we see which command is running currently. So that is okay. When this container was created, since when it is running, and then we see ports. So this ports column is interesting. Actually, it is saying that all the interfaces available within the container, actually this 0000 is for all the network interfaces. for port 53 are mapped to port 53 on the host machine on the TCP network stack. Similarly, port 80 is mapped to port 80, and UDP port 53 is again mapped to UDP port 53, and 67 is mapped similarly. So it gives me the details of how ports within a container are mapped to the host machine. Of course, two containers cannot map the same port on the host machine, so we can remap to a different port number. But once this port is mapped, I'll show you how it runs a software. So just 1 minute. So I am going to a website. Just I have to use it. Okay. IP address. Okay. So we see this, and this website is running. And the interesting part is this website is running within this container. Or if we want to see how much resources this particular container is using, we can first find this. So it will give me more like details about Docker, what is running, what software are running, what volumes are mapped, and a lot of details. But if I just want to see the resources, I can issue this command. Oh, sorry, Docker top, and I hold is the container name. So it is giving me the data. So which PID is running, which PID is using how much memory, and what was the start time, and other details. And there is one more thing. So out of 1 GB of memory, my entire container is using only 58.52 MB. This is the IO, and this is the block storage IO. So we can run multiple containers on a single host machine, and that is very resource efficient. CPU resource is very minimal, and what that website is using, we will come to that point also, but this is the interesting part of running a container. So I will come out of it, and we are going to briefly touch upon one more topic, which is called swarms, or what is the purpose of swarm, and what other technologies are available. We will discuss this also very briefly. We are not going into much detail now, but basically when we are running a container, what we can do is we can run some application or some operating system within a container on a host machine. But if we want multiple containers to run together as part of a cluster, what we can do? So that is what comes as a swarm. So we can run multiple application servers as a swarm. They can scale up or scale down as per the requirement. So for example, if you are running a website, and if we want if you see that the number of users of that website is increasing, and you want to increase the number of application servers that you are running, you have to just increase the swarm size, and it will scale up automatically, and it will run more containers to serve additional users. So that is very easy to manage, and Docker supports that capability. If you want to learn more about it, how a swarm can be run on a Raspberry Pi system, you can go through this link. I will share this PPT, and we can go into more detail after that. But for example, if I have 10 different Raspberry Pi running on my network, and if we want to run some software as part of a cluster on that all the 10 Raspberry Pi computers, I can do that. If I am running some different hardware also, I can probably set up a container to run across different OS and or different hardware as well. But there are some limitations to them. But that capability is there. Now we are touching like Docker swarms. We are touching one more topic, which is called Kubernetes. So Kubernetes is a similar technology for containers. It is also open source. It is orchestration platform initially designed by Google to manage their own containers, and then they donated this technology to the public domain. So now multiple companies and like institutions are using this. Kubernetes is more complex cluster structure than Docker Swarm, and it is of course used to create clusters of containers, but it has different components. It has a builder and worker nodes as per its architecture, and these are divided into different pods. So we call the running node as a pod which is running. It has its own namespace. We can map the configurations and so on. So the Kubernetes has a more complex architecture. It requires more resources than Docker, but the good thing is we can run Kubernetes over Raspberry Pi device, and even on a Raspberry Pi 3 OS or Raspberry Pi 3 hardware, we can run Kubernetes. How we can do that? So there are some advantages of Kubernetes. We will see that it has a large open source community. Google backs that community. It supports almost every operating system. It can sustain and manage large architecture and complex workloads, even if some of the nodes or the ports are not working or like down due to some failure. Other ports in that cluster will automatically load balance and take the work. So it has automated self-healing capacity, automatic scaling capability, and built-in monitoring and wide range of available integrations with different systems. And the most interesting thing is it is supported by all the three major cloud players in the market: Google and Microsoft and Amazon. So now we are coming to the point how we can run Kubernetes on the Raspberry Pi. So there is a very lightweight version of Kubernetes available, which we call K3S. And it is a single binary, which is production ready, easy to install. And the size of that binary is less than 100 MB. You have to just install that, and it provides all the required capability to run clusters on Raspberry Pi computers, and we can run the containers inside it. Right now, we are not having a demo of it, but if anyone is interested in running Kubernetes clusters on a single Raspberry Pi or on multiple Raspberry Pi, it can be done. You can contact me separately. We can work on that. But yeah, this is an interesting technology. And one more interesting part is it supports ARM architecture. So it runs on ARM 64 and 32. I think 32 support is not available yet, but ARM 64 support is available. Okay. So there's one more slide available on this topic. It is fully conformant to production ready Kubernetes distribution with the following changes. It is packaged as a single binary. So if you want to install K3S, you have to just copy that binary and run it. You are not required to install multiple dependencies or anything. It had support for SQLite 3 as the default storage backend. etcd3 and MySQL and Postgres are also supported. Multiple storage backends are supported. It wraps Kubernetes and other components in a single simple launcher, which is good. Not like full Kubernetes, which in this terminology we call that K8S. The scaled down version that we are seeing here is called K3S, but the full Kubernetes is called K8S. So it is just in comparison to K8S, we are seeing this. Sorry. So it is secure by default with reasonable defaults for lightweight environments. It has minimal to no OS dependencies. just the same kernel and C groups mount needed. It eliminates all the need to expose a port on Kubernetes worker nodes for the kubelet API by exposing this API to the Kubernetes control plane nodes over a WebSocket tunnel. So this is more technical part, but yeah, it is interesting to see that we can run Kubernetes on Raspberry Pi. The next thing, containers part is finished. Now we are coming to Python, and what like I think almost every one of you know that Python is interpreted high level general purpose programming language, which is very popular almost on Stack Overflow developer community. It is rated #1 since multiple years. Now it has like Java is on the second position, Python is on #1 position. So we read all about those things, but the design philosophy emphasizes that code readability with its use of significant indentation. The language constructs as well as its object-oriented approach aim to help programmers write clear, logical code for small and large-scale projects. And I like Python programming for one simple reason, that we can do very complicated things rather easily in a Python program, which requires a lot of code and structure, etc. in other programming languages, but Python doesn't need anything. It's very simple to program in Python. So that's what I like about this programming language. And we in this slide, we will learn about different ways to set up Python on Raspberry Pi. So we are going to discuss this because these different ways are for different purposes. So we will learn what are those different purposes, but we will just touch upon all the ways we can install and use Python on a Raspberry Pi system. So basically on Raspberry Pi and similar OS, we install Python for two purposes. One is for development. So if you are a developer, you can use Python to support your development work. But when you develop your software, you have to deliver it. You have to give it to someone who will use it for the desired purpose. So the problem with Python programs are that it has a lot of dependencies. There are a lot of libraries that you install while you are developing a Python program, and you have to deliver those things. One easy way that we have learned earlier is we containerize everything. We containerize all the dependencies and run time libraries into a container, and then publish that container, and then give that container to the person or the institution who want to run that program. That is okay. That is absolutely fine, and it is a new way to do that. But there are other ways also which we can do. So we will learn those. Those are more traditional ways to deliver applications, and we will see about that also. So first thing is the most traditional way of installing Python on an Debian based operating system is using the system package manager. And every operating system, Linux based operating system, comes with its own package manager. So for example, in Debian operating system based distributions, we have a package manager called aptitude, which is the command is apt. I will prefix it with sudo apt, and then I'll just list down what I have installed on this machine. So this is the list of all the software available in their library, and I think I have to put this switch, then it will list down all the software that is installed on this machine. So earlier what was available is listed, and now it is listed what is installed, which is okay. A lot of software installed, and we see that Python is also installed, and along with it, its libraries and different versions are also installed. So this is the first way that we are seeing, using the system package manager. So how can we install Python using the system package manager? Very simple command. apt. Of course, I have to prefix it sudo if I am not running as a super user. Install and Python. It is sufficient to install the default version of Python on this. But what happens? Sometimes you don't want to put everything in your machine and you want to keep it separate from all whatever is available on the machine. So the other way is to install it as a Docker container. And for that, we have already seen this command. So it will download, install, and run that Python program. And you can use it for running your applications also. So that is also absolutely fine if you want to develop on your machine. And if you want to remove it, you will just remove it with a single command. So these are the two common ways to install Python programming language and corresponding package in the OS. But when we work on large applications, the things go in a different way. We need not only the Python programming language, but we need different libraries, different packages that are required by our programs to run. And for that reason, we need some kind of software that can manage all those libraries and packages. And if you are working on multiple programs, then you may need different environments also to manage those programs separately. So now we will come to those points, like how can we manage. So for example, if you are working on 3 different Python programs for different clients or any reason, if you are running those programs on your machine, you want to set up that. So how can you do that? Can you use the single Python language that is installed on that machine for all the development work? That can be possible if you are using a single version of Python for all the programs. But what happens if, for example, for one client you are using Python 3.10 version, for another one you have to use Python 3.6 version because that client supports 3.6 only. They don't want to upgrade to the latest version right now. It has some incompatibilities with their software. So this kind of situation happen in a practical world, and you have to maintain different versions. So the next command that we are going to learn is how to install different versions of Python on a system, either globally or locally. So the command that is available for that is pyenv. So you can easily install pyenv, that very simple command. And this pyenv gives you the ability to manage multiple Python environments on a machine. And we are running it on Raspberry Pi right now. So if you want to see how many Python environments are installed, first, this is the current version that I am using. And if I make it a plural command, it will show me all the versions. So it has a system-based Python, which is already we have seen using apt command, which is installed on the OS. The second is Python 3.1.10.0, which is the latest version. It has a star, which means it is the default version. And it also has an old version, which is called 3.8.6 installed on this machine. So what if I want to run some other version, not the default version? I can easily do that. It has some sub commands available. We can easily see those commands, and then we can use that. So for example, if I want to make 3.8.6 as a default environment for local, then this is my local. And if I run Python from command line, now it is running 3.8.6. So which is what I want to use. Now I want to go back into the OS and I want to use another version. So I will, sorry. It is changed to 3.10. You can see in my prompt also, it is now showing the other version. It is very easy to switch between different Python versions and use that on a single machine. But we have one more problem here: how to manage the dependencies of our programs. If we use programs which have used different libraries, then how we can manage that easily for Python programs. So then there is another software for that. Actually, there are commands available to manage virtual environments, venv, virtual env. Those commands can be used, but those commands can also be used in a more easier way. So what I do is I use pipenv for my Python applications, and this pipenv actually can easily set up a development environment and all the dependencies of my programs in a single machine. And if I work on multiple programs, it can manage multiple environments very easily. So for what happens when we work on Python, we install multiple libraries using pip command. You all must have known this. And this pip command has a lot of options. And if we just list down what packages are installed, so by default, these two packages are available. But if I want to create a new environment which is separate, pipenv is not currently installed on this machine, so I will not demo it. But using pipenv, I can probably show that on my dev machine if it has it. I don't know right now, but let me check. Yes, so I have one pipenv on my Windows machine. We can install it on in this also, but if we just install it, for example, I created a new folder and I want to install pipenv. This is the command. It will create a new environment of Python using whatever version. If we want a previous version of Python, we can easily use that also. And then it has done everything. It has installed all the dependencies that we need, that come by default also here. And then I will go inside that shell of pipenv. So how it works is, this pipenv environment is available within this folder only. So all my work I can keep in this folder. Then if I want to install some dependencies, I will go into pipenv shell. Okay, so this is done, and now I am within the shell. Now if I install some library, for example, this library, if I want to install, it has installed this library. Now if I list the libraries, I will see this Cause package is installed, version 4 of this package is installed. But if I come out of this shell, just a minute, not able, okay. So this does not have it because it is, my global pip package is different, and my environment for this particular application demo 1 is different. So it is totally separated. Whatever I do within this shell will remain here, separate from all other applications, and I can do anything. I can install all the dependencies, I can package them, and when I have to deliver my software, I can easily package all the libraries and share it. So this pip file actually lists down all the software that I'm installing as a dependency. So to keep separate development environments, pipenv is very useful. A similar concept is also there, which is a new, rather new concept, which is called poetry. It is also similar to pipenv, but the difference is it uses TOML format file for configuration and associated dependencies. So you see here in pipenv we use pip file, which is a common Python pip file format, but poetry uses TOML. So that is a basic difference. And there is one more interesting thing I just want to share. If we want to install some Python program, but not all the dependencies and other things into our system and keep everything separate. So for example, if you want to just install Cause program on our machine, so we are not required to use like full Python environment for that. There is an interesting command pipx available, and we can just use this to install global programs. So it is already installed. So it's say that, and if I run it, so this we can run it directly. We are not required to run Python and then run that library. It will install on my OS. Any Python program I can install using pipx with install command. Of course, it installs from the pip library only, but it installed independently on the OS. So these are different ways to set up a Python environment on our machines. There are more ways also. There are low level commands as well, virtual environment, venv and other, and we are free to use those commands as well. But here I've just described some of the ways which I find easy to use. Okay, we will move to the next slide. So this is the topic that I have not touched earlier, and I discussed that we will touch. So there is a scaled down version of Python programming language, which is more suited for microcontrollers. So the IoT devices that we say. So that version is called MicroPython. And it is a lean and efficient implementation of Python 3 programming language that includes a small subset of Python standard library, and it is optimized to run on microcontrollers and in constrained environments where we do not have much resources and we want to. And so we generally we do low level programming on such devices, but MicroPython is something that we can use in such scenarios. So MicroPython is packed full of advanced features such as interactive prompt, arbitrary precision integers, closures, list comprehensions, generators, exception handling, and more. These are common features of Python programming which are available in MicroPython as well. Yet it is compact enough to fit and run within just 256K of code space, which is excellent, and only 16,000 bytes of memory. MicroPython aims to be as compatible with normal Python as possible to allow you to transfer code with ease from desktop to a microcontroller or embedded system. If you want to learn more about MicroPython programming, you can go to this link for further details. Right now, I do not have any device to demo this MicroPython in this session, so I'm not going into more details, but yeah, we can learn more about it using the given link. Okay, so now we are going to see some of the interesting implementations of IoT projects using Raspberry Pi. And I know you all must have gone through these earlier, but I'll just showing down some of the interesting things that I have learned on this technology. So one thing is weather station. So these links actually have all the details for what equipments are needed, how to set up those systems, and how to interface with Python and how to run that. So this weather station basically gives us different weather related information, and it uses some sensors, and there is a HAT device which is installed on top of Raspberry Pi. So this is that HAT device. It uses the GPIO pins for integration with Pi, and then we run some program which is written in Python and which captures the data from the sensor and works as a weather station. So it provides the data back to your library, and you can actually interface, or you can connect this program with other monitoring system or a dashboard like utility. So you can display that in a website or a dashboard or anywhere. If you want to log that and keep it for historic purpose, you can do that as well. So I find it as a interesting implementation, and if you want to deploy it, you can use this link. And if you want to discuss these projects with me, you can reach out to me. I will share my contact details as well, so anyone can reach out to me. This is one topic. We will go to the next one. It is also similar, but a different sensor is used here in this scenario, and they are monitoring the air quality. So this measures the CO2 concentration, the CO2 level, the temperature, humidity, and air pressure that is available on the sensor. So how it can be done, again, step by step guide is given here in this link, and it has a list of all the devices that are required for this air quality monitoring system. So we can create our own website using this. So this is the second topic. The third one, interesting one, is smart home hub. It is similar to what we discussed earlier. Right now, actually, we have one product in market which is called Philips Hue, and that Philips Hue bulbs are Wi-Fi enabled. They can connect to the Wi-Fi system. You can give instructions, but they require a hub device to be installed on your home network to control these bulbs. They can like light in different colors, different intensities you can control. You can even make them play on different colors according to the music you are playing in your TV or some other device. So there are interesting things in this, but in this particular use case, we are seeing how we can set up a hub using Raspberry Pi. So this is that topic, and the next one is for energy monitoring system. So how much energy is being used on a electronic device or in an electric system at your home. You can create that system. It is easy to set up. The interfacing details are given, circuit design is provided, and we can use this to set up a monitoring system. So energy monitoring give you data for like a historical period also. You can see how much energy consumption is there. This is the code, which is in Python 3. And this is the system demo. So go through this as well. And the last one that we are going to is smart mirror. It is also very interesting thing. And we need a Raspberry Pi 3 or 4, a HDMI micro USB device, a computer monitor with wooden frame, and a two-way mirror is required for this. So what a two-way mirror does is it works as a mirror, but it also has a display here, LED display. So you can actually use it as a dashboard for, you can install it at your home or at workplace, and you can share some information. So for example, if in your uh, like lab or somewhere you want to display some notice or something, but it has dual purpose. It works as a mirror also, and you can have your information also displayed on that. And this is the entire code and details of how this project can be set up and how it works. Okay, so these are some projects that I liked and would like to work with any one of you in future. And the next one is one thing that I have set up, and I actually showed you also earlier. It is not very specifically related to Python programming, but it is easy to set up, and I am using it since last few months. So I would like to share that. So we all go to internet, we different like we visit different sites, and we see one problem, that there are a lot of advertisements on internet, and it is okay to, like for example, if I am running, I can run some ad blocker like I am running currently in my web browser here also, uh, and this uBlock origin is blocking some of the ads, but it is not easy if I'm running it on my smart TV and some advertisements are running there. If I'm running on a tablet and I don't have option to install any add-on on that tablet or any other device on my home network, on any phone, so it is very difficult to manage these ad blockers across all the devices. So I was just curious if there is any way to do it at a network level, and there is a way to do that, and this is how it can be done. So we will learn about it, and this is the same thing that was running in my Docker container. So we will go back to our Docker on Raspberry Pi, and when we see this, you see this Pi-hole container is running. And what is this Pi-hole? Actually, I showed earlier that it is running this website. So we will go back to this website. Okay, I will log in. I have not logged in through this laptop long time. So let me log in there. Okay, I think I have the password. Okay, so it will show me what is happening. So total DNS queries that my network is generating and how many are blocked. So for the some 7 machines are connecting to this DNS server. We about 13,000 queries were generated in last, I think, 24 hours, and it has blocked around 25% of those queries because those were advertisements for different servers. And I am currently blocking about 1,08,000 domains using this DNS server. So how it works and how I can set it up, and what devices, like this is my phone, this is my office laptop, and this is another device, this is Raspberry Pi. So what devices are connected, this is a printer. So that details are also there, which domains are blocked, which domains are allowed, and we can get more detailed log also. We can have more customization also across the services running inside this. We are not going into more detail because it is very close to end of the session, but I will just show how this can work and how to set up this Pi-hole based DNS ad blocker on Raspberry Pi. And it is very like less resource consuming. So we'll just come to this. So the first command on a Pi, because I am setting it up inside Docker container, so we are not installing it on the Pi directly. Instead of that, we are running it inside a Docker container. So what command I have issued for this is see, this is the first command, docker pull pi-hole/pi-hole. It will download the image of pi-hole based container. So it is already downloaded, so it will not do anything in my case, but this is the first command that I have to use. It is already available, up-to-date image I have on this, so it is okay. Then there is a configuration file that I can update to make the required changes. So if I want to use some different, sorry, I think I can use this. Okay, yeah. So I have to change this configuration file. We will see where it is changed, and then I have to issue this command to run the container. That's it, and the DNS server will run. Everything is configured and available. Very minimal 2 or 3 line changes are needed just to specify your IP addresses, etc., which you have set up on your home network, and then everything works just pre-configured. So for this, if I want to go inside the container, first we will try that. Can I go inside the container? Yes. Okay, so using this command, I did not run any new container. Instead of that, I used the existing container and executed one command on that container, which is already running a web server software, but I connected to that. I attached my console session to this software, and now I can go inside and see whatever is installed, whatever is visible, like set up on this container. I can go inside that and do everything. So how that container works, if I want to go into deeper details, I can go in this and find that out. If I don't want to go into the details and just see the configuration file that I have updated, then I can probably do that also. I have to figure out where I have installed the file. Okay. Okay, so this is the place where I decided to keep the files of this configuration for this container. So it is here, and I can use editor. So you can see these are the IP addresses, these are the ports that I have specified, the time zone that I want to use, and that's it. If I specify all this stuff and then just run that command, docker compose, then it launches the container. Now, once the container is launched, my DNS server is running, but I have to configure my router to use this DNS server. So that is what I have done on my router. I can show that also. So this is my router interface. I am using a custom ROM on this router, so it has some extra capabilities. I am running a VPN server also, so I can connect to my home network from anywhere in the world. And I have also has a dynamic DNS system published, so my router is available on this address as well. So those are different things, but how I can configure the DHCP server or DNS server, it is here. So in this DHCP server, what I'm doing is, as a DNS server, I'm giving the IP address of my Raspberry Pi so that it will force all the devices to use this DNS address for any domain name translation. So if a domain name finds, if a domain name is in the blocked list, then it gives a 0000 IP address, and that thing doesn't work. So I will just give a brief demo how it works. So for example, I will just turn off this ad blocker which is running locally to actually show what happens. So you'll see this is a site where a lot of advertisements are, we see generally. One more thing, actually on this particular device, I'm not using the ad blocker right now. So I have to first set up on this device. So for that, nothing is needed. This is a device. What I have to do is I have to just edit this. And provide the address. So okay, so it is done. I will go back to my system. I will go to my local computer and see. Okay, so no, it is still not using. I think because I'm using from the same network, I let me use my different system. Just give me a minute. Okay, so now I have connected my another laptop, and because that laptop has this this DNS server enabled, so I will demo on this. Uh, so can you actually I have connected this meeting with another ID also. Can you allow me to share screen?
Yeah, yes, sir, please. Can you tell me you have logged in with which? Can you tell me the ID or name with which
It
you have
has my
logged in?
name and #2.
Yeah, yeah, sure. Give me a second, sir. I will just do it. Yes, sir. Now you have the rights.
Okay. So, okay. So, okay.
Yes, sir, it is visible now.
Yeah. So I'm just coming to this same website, and you will see no advertisements are visible. We see it as blank area, and it is because on this device the ad blocker is blocking all the advertisements, and even the web browser based this uBlock origin is also disabled on this side, but even then nothing is, no ads are visible. So this is interesting because on all the devices in my network I can use this, and in the router there is a way to enforce the DNS server also. So if a device wants to change the DNS server, it will not be able to do that. So that is another thing available. But if I just disable this ad blocker for a brief time, I can do that. Just one more minute. I have to log in into this. Okay. Okay. So what I'm going to do is I will just disable this system for 5 minutes. And then I will go back to this site and I will refresh it. And the advertisements are back. A lot of advertisements are there. So that's how it works. If I enable it again and then run, then these will block again. So it works for the entire network, for all the devices and on very low resources. So that's how it works. And that's it. All my slides are done. If anyone has any question, please let me know. And otherwise, we can close the session. Am I audible?
Yes, sir, you are audible, sir. Some questions has been posted on this chat box.
Okay, yeah, I'm opening it. Yes, we can measure power consumption in Raspberry Pi, and it is possible using some commands available within the Pi. And also there are some devices available which can actually measure it from your power outlet also. But we are not required to do that. We can just simply go into the Pi, and I can probably figure out and share those commands also. It can show you how much power is being consumed at a time, at a given time, or if you want to monitor the power consumption over time, then I have already shared one project in one slide. So we can use that, and we can measure the power consumed by Raspberry Pi, for example, in a last 24 hours or things like that. And the second question is it possible to do image processing, like for example, face recognition using Raspberry Pi? So technically it is possible because we can run those libraries, those programs into run within the Pi. But the problem that we face, and for example, if you want to do some kind of learning for your AI system or the recognition software, you want to make it learn from a vast library of images, then their Raspberry Pi may not serve as a device of choice because it has not that much of computing power. So for that if we need more computing power, we may of course create a cluster of multiple devices, but definitely a more powerful system is better suited for that purpose. The third question is, can it be used as a server? Definitely, it depends on the use case. For example, as a web server, we are currently using it for a small network. But if we say that we want to connect 500 clients using a single Raspberry Pi, that may not be the best uses. Yes, we can create a swarm or a cluster of multiple Raspberry Pi to serve as a scalable server. But this depend on the use case. For a small website where not many users are there, you can definitely use Raspberry Pi for that purpose. It can run 24 hours. It will not consume much power. It will not make much noise, and you can just directly connect it to the network and it can serve. You can even run a dynamic DNS or something like that to because ISPs in India do not provide a static IP address, and if you want to run a web server or something like that, you need a static IP address. So instead of doing that, you can set up it through the dynamic DNS service, and which will automatically update your IP address to the on the domain name. So it will connect to that. I can provide more details on that, and you can contact me for that purpose if you want to do that. Next question is, in Arduino, MCU, Node, and Raspberry Pi, which one is most secure device? So again, it depends on the use case, I believe. So the secure device means for example, if we are using it on our network and we are exposing it to be able to connect from outside world, then definitely Raspberry Pi is not that secure because it can be connected, but it depends on our configuration. For example, if I want to access my Raspberry Pi from my office network and it is installed on my home network, so I can do that, but I am running it behind a VPN system, and that VPN is running on my router device. So unless my VPN is cracked or someone knows how to go inside my VPN, and they cannot connect within my network. So that is how I make it secure. For Arduino devices, it is basically generally not exposed out to the outside world. But if we are exposing some device, then also their capabilities are limited. So the security is also like it is a subjective matter. It depends on how we configured it and how we are using it. The next question is, which is better, Arduino or
Gaurav
Raspberry
sir,
Pi?
sorry to interrupt you in between. Actually, we are running short of time and we have the next session and our speaker has also arrived. So please
Okay.
wind up.
Sure.
Yeah, sure.
Sure. So the last question is, right now I don't know the question, Arduino or Raspberry Pi to perform edge or fog computing, but I think I will get the answer and share it with Yogendra in future. Thank you so much for this session and for all the organizers. Thank you so much.
Thank you so much, Gaurav sir, for sparing your precious time with us. Thank you. Thank you so much, sir. I think. All right. Good afternoon to all once again. Dipankar sir, am I audible to you?
Yeah, can you hear me?
Yeah, yes, yes, you're audible.
Great, great.
Good afternoon, sir.
Thank you.
Dear participants, now we have with us Dr. Dipankar Dev. He is a senior member of IEEE and has served a couple of years at IIT Guwahati as an assistant professor. He has over 6 years of industrial experience. He received his PhD from University of Virginia, Chevrolet, USA, and master's from University of Florida. He is currently working as professor in Institute of Infrastructure Technology Research and Management, Ahmedabad. He holds 6 US patents and 1 Indian patents and has published 40 SCI journal articles and 40 plus research papers in various journals and conferences. He has authored 11 books. He is recently listed in the top 2% of researchers worldwide for 2021 as published by Stanford University. Thank you so much, sir, for accepting our invitation.
Thank you. It is my pleasure.
Now over to you, sir. Tuin ma'am, please stop sharing the screen.
Is my screen visible to everyone?
Yes, sir. Yes, your screen is visible now.
Great. So my talk for today is actuator and sensor uncertainties and challenges in IoT framework. So basically, Internet of Things is the buzzword now, and the theme of this workshop is also Internet of Things. But actually, the Internet of Things has not originated. The terminology has originated recently in the last decade or so, but it has evolved over time in the sense that before Internet of Things, the terminology that was used was industrial internet. So that is large corporations like, let's say, General Electric Company, they want to connect their different hardware, different locomotives placed in different regions of the world and optimally use resources so that they don't have to replicate the same locomotive in two different research labs in two different continents, but can run programs on each of them. Let's say, for example, General Electric Company's Munich division wants to run some program on a locomotive which is based in General Electric Company's research lab in Bangalore. So for that, they developed a terminology called industrial internet. And so for that, actuators, sensors, these were needed, and that is how this application or such a concept called Internet of Things evolved. Okay, and why the term Internet of Things is very popular now is because now it is no longer about connecting large locomotives which are in two different continents and then making them to talk to each other or access data from them and anymore. Now it can be very small things of, let's say, monitoring the moisture content in the crop in a particular village. And let's say large farmer, you are aware about the farmer agitation. Farmers are not always, it is not necessary that they will only have one plot of land. They can have several or huge plots of land across multiple villages and all, but they may want to monitor their the productivity, the moisture content, the nitrogen, phosphorus, and potash, the NPK content of their of a particular crop or the soil in that particular region of his land remotely from his home, let's say, or from one farm to another farm. So for all such activities, now in Internet of Things is the terminology that is being used. And in the context of this, another thing I would like to just state while I get into this is there is also the concept of cyber physical systems. So cyber physical systems, and so one should have little familiarity across all of this. Cyber physical systems is also almost this same thing, except that in cyber physical systems, this internet, the network of all the devices is part, but also physically individuals, human beings are also part of that. Okay, and physical devices in different locations. So that's why it is called cyber physical system. But ultimately, they all work through these actuators and sensors. So my focus for this talk would be how to optimally utilize these actuators and sensors, and when there are some uncertainties in them, how to deal with them. Okay? Because when you install an actuator, why there would be uncertainties? Because when you install an actuator, for example, it changes its properties over time, okay, due to aging and due to other uncertain parameters. You cannot every time replace that actuator with a new one. Okay, sometimes it is being operated remotely and things like that. So in a large number of cases, you may be able to continue with the same actuator if you can identify the kind of uncertainties that are there. So that is why the topic itself is relevant. Okay, so let's look at what we are going to cover today. So a brief overview of this IoT system involving sensors and actuators. Why am I focusing on that, on the points of sensors and actuators? And then even among that, my main focus of this talk would be on actuators only. And I will also tell you what structurally and mathematically and in terms of the IoT, how the actuators and sensors are different. I'll be talking to you about because we are going to talk about uncertainties in actuators. So when uncertainties are there, like I said, you don't have to replace the actuator, but you need to study the nature of the characteristics that this actuator is showing now. And so you have to compensate for any uncertainties that evolve over time or due to under any specific condition. Maybe the actuator is a mechanical valve in a particular case, let's say, and now it got stuck. So there are multiple of such actuators. Can the other actuators among themselves divide this task that this particular actuator which has now got stuck at a certain level, the remaining part of the work that this was going to do, can the other actuators do that? Okay, so for all of this, we need something like an inverse compensation of this model. So I'll be talking about this particular work, and all of it involves this concept of model reference adaptive control. Okay, and why we are talking about control of these things? Because because control systems is not new like IoT, for example, but control systems primarily relies on actuators and sensors. And when there are, an IoT system also relies on actuators and sensors. When everything is working fine, you don't need any compensation or control in an IoT framework. Or I should say any supervisory control. The normal basic control is always there. But whenever there is any failures or any changes in the characteristic of such actuators, we need to have an automated control mechanism. Okay, so that to explain that, I will be talking about this model reference adaptive control. Here in this particular case, as you can see, we are going to talk about an aircraft where we are going to prevent aircraft from stalling. Stalling means if an aircraft is flying and if there is no sufficient, by Bernoulli's principle, the pressure difference across the two surfaces allows the aircraft to fly. Okay, the most basic principle why any object can fly is because of the pressure difference across the two surfaces, the upper and the lower. Now, whenever there is stall, that means whenever there is not sufficient airflow attached to this surface, okay, what will happen is that the amount of lift force that is required to keep the aircraft flying means the lift force that is required to keep the aircraft flying is not sufficient. So in that case, the aircraft will crash. So to prevent it, how can we keep the flow reattached to the surface? We can do something in control so that the stall will be delayed. Delayed means if the stall was happening, let's say at 15-degree angle of attack. Angle of attack means the angle that the aircraft is making right now with the horizon. Okay. if the stall is happening at 15-degree angle of attack, we can do something, some kind of actuator compensation, which can delay the angle of attack, delay the stall angle to, let's say, 25 degrees. So now the aircraft can make a sort of like as you have seen in fighter aircraft, they can make this kind of motion, right? And they can go up and down, such kind of motion. So the stall angle, that is the angle that is, or the angle of attack, which is the angle that the aircraft makes with the horizon, that angle can be increased by this actuator compensation. So anyways, that is in reference to aircrafts. We will also be, to show you the great diversity of this kind of work, I will also be talking about IoT framework in the setup of an artificial pancreas. What is an artificial pancreas? It is a replication of the naturally present pancreas in our body, but when under type 2 diabetes condition, or T1, TIDM, the under type 1 diabetes condition, the type 1 diabetes mellitus condition, the secretion of insulin, when it is not enough, when it will, or when it is depleted, then what will happen is you are now reliant on insulin from outside, that is through an injection or insulin tablets in the morning every day to control your blood sugar level. But artificial pancreas is a small device that you can keep on the right side, just above your belt, which can secrete insulin at regular intervals based on the need. So it's a closed loop system. It monitors the blood sugar level. So this is still in research phase, released for clinical trials and all, but not fully, the FDA approvals and all have not been fully given yet for large scale production for this. But in terms of research, a lot of work is going on, where now it can do, through using an IoT framework, it can regulate the blood sugar level of your body, and it can also, your doctor remotely seated, let's say a patient is in an old age home and having artificial pancreas implanted on the body. If there is any sudden fluctuations in the blood sugar level or anything like that, he or she can be remotely monitored using IoT framework. So we'll be talking about that as well. Okay. So basically, so with that sort of a detailed background of what I'm going to talk about, let us look at the IoT system in terms of sensors and actuators, what it really does. So let us talk about this in terms of a simple example of a hydraulic system, where a temperature monitoring system, where sensors and actuators can be used. So basically, an IoT framework which has appropriate sensors and actuators, it adds, what does it do? It adds intelligence. It gives you a smart system, okay, which to your existing system, if you can connect it, you can connect some smart electronics to it, okay, along with sensors and actuators, which collects data, which basically monitors several things, okay. It can provide you with relevant information when needed. Now that's a long statement, but let me give you an example. Okay, I'm sure you have seen a door stopper. Okay, we have recently got a granted patent on a smart door stopper. So let me give you a brief explanation of how the intelligence in the IoT system is utilized for data capture and for provide and performing some intelligent decisions. So a door stopper, you know, it is a device, it's a control system. It's a mechanical control system that you have on a door when the door is, let's say, open at by around 45, 50 degrees. Okay. If you leave the door, okay, now it is closing. So in the beginning, it will close fast. Okay, so the speed at which it is closing is high. But as the angle reduces, means when it is, let's say, 15 degree or 20 degree, now the speed at which the door is closing is slowed down. So this door stopper is doing this. Okay. So as a result, what will happen when the door closes, there will not be any significant amount of noise. There will not be any third sound, right? So it will smoothly close. So this is the mechanical functioning of a door stopper that we know for almost 30, 40, 50 years now. Okay, maybe more. But if such a device externally, it looks like a door stopper, okay. But if you can bring in some electronics into it, and if it can give you some monitoring capability, and if it can be remotely monitored, okay, then you are gradually having an IoT framework in that door stopper, and it is becoming a smart door stopper. Okay, so so what we did, we brought in some electronics. Okay, so we had a Raspberry Pi Zero, which is a very small size device, which actually fits into the blank space that is already there in most door stoppers. If you look at it from behind, okay, if you open it up from the door, and if you look at it from behind, there is a hollow space behind. So if we bring in some smart electronics, that means not a large sized assembly, not a large size device, let's say, because that will not fit. If you have to fit it, you have to change the structure of the door stopper. So it will now no longer look like the regular door stopper. So we don't want to do that. So we choose such type of electronics, a pencil camera, a very small one, and recording devices and things like that. Using a Raspberry Pi Zero, it is the smallest size, comes in only about $5. Okay. So we incorporated that. Now, simply if I make a door stopper, a mechanical device, and put some electronics, and now, of course, it does recording and all these things, right? Then it doesn't become an innovative idea. Why? Because such electronics already exist. Okay, and you should question me that why should a door stopper, which is mechanically already there, and such electronics which record and which does some programming for operating anything, if you just merge these two, why should it be a sort of a non-obvious invention, non-obvious idea? The reason it becomes a non-obvious idea is this, that if you connect if you program your such smart electronics in such a way that now it optimally controls the mechanical device. That is, for example, the battery that is required to operate this, okay, the electronics which turns on and off for recording any intruder who is coming in, let's say, all these things, if you can do it in such a way that when there is no one at the door, everything is switched off. It is not a sort of a ASDN kind of thing, that always on dynamic ISDN. It is not such a device. It will turn on only when it recognizes some person is now trying to enter. Okay. And this is one reason. That's why it is optimally used. So that battery you don't have to change very often. Okay. And also it is connected to the angle at which it is opening. If it is opened more or if it is opened beyond a certain threshold, let's say more than 30 degrees, then only it starts clicking picture of that person. Because if the angle is very low or very small, then the person would not have fully come, and so his picture, if you take, you will not get a clear front on picture. So by doing all these things, you make the mechanical device and your smart electronics operate interdependent, being interdependent while operating. And that is why it clears. So there are 3 requirements for any innovation. The idea should be novel. So novel means if you just take a car and a small aircraft, if you connect them and now you sit in the aircraft section and you fly, or you sit in the car section and you drive, the idea is novel. It is a flying car, but no one will give you a patent for it, because car is also existing, aircraft is also existing, and you have not optimized anything. You have simply just sat on different section and you are flying or driving, right? So, but that is still novel. The idea is novel, that you wanted to make a flying car, right? So you think about 50 years ago when this idea of flying car was there, or first invented, I think 1982, the patent was given not because of simply connecting like this. The patent was given because you optimized the dashboard, you optimized the engine, you modified the of course, you know what is required to fly and you know what is required to drive. Okay, but you optimized everything. Now that the vehicle that you made, it optimally does both the things. Okay, of course, different things at different times, but optimally does both the things. It doesn't have 2 dashboards. It doesn't have 2 different engines. Okay, so it optimally, when you have made, you have restructured everything. But of course, you are inspired by both of those existing things. Okay, so that is, then it clears the requirement of the second requirement. First was novelty. The second requirement is non-obviousness. So it clears that requirement. And of course, the third requirement is that commercializability. That is, you should be able to commercialize that product. If you just come up with some theory which doesn't have monetary value in terms of someone wanting to buy it, so that third requirement would not be satisfied. So all these 3 requirements, when they are satisfied, then you can make a product. So this smart door stopper that I was talking about, on which we have a patent that has been filed and published. It is in the first examination report phase. That does these 3 things. Okay, so that is, after all, an IoT framework system. So anyway, so that's the background for how such sensors and actuators are working in an IoT setup. Okay, so for example, here, let us look at this. Okay, you have a sensor. Okay, so it's a temperature sensor. It will detect some heat. Okay, so let's say you have installed this sensor. It is detecting heat. It is similar to your fire alarm smoke detector, for example. Okay, so smoke detector is detecting amount of, if you leave the stove on, okay, and you have gone for a walk, and now the smoke alarm will come on because it has been a while and it is crossed a certain threshold. So that kind of sensor, let's say temperature, a heat sensor, is shown over here. Okay, so what it does, when you have crossed a certain threshold, what it will do, it will send this signal to the control center. Okay, if you are having simply a smoke detector in your home, okay, it may not do both. Means it may simply, that smoke detector may simply be designed such that it tells you by making some noise that there is a smoke in the house. But if it does both the things, it of course does this for you to locally try to handle it. But if all such smoke detectors, for example, of a particular apartment complex are connected to the control center in that apartment complex, let us say, okay, then how, so then it is the beginning of this IoT framework. So what it does, it will send this signal to this system, okay, to that control center, that now in this number flat, this particular flat, as there is some issue in the, there is some smoke, okay, so, or a particular, this heat sensor will tell that, okay, some place is, there is some smoke or some fire, something like that, is some, whichever way you configure it, it is now able to communicate to the command center that something is wrong, okay. Now there may be a way of handling this. One way is that, let's say there is some fire, if it is, then you want to bring in the mechanical way or the manual way of doing it, is that fire pilots should come and do it. If it is a high-rise building, then through drones, okay, my colleague Dr. Abhishek Rawat will be presenting in the next session, IoT framework with drones. So there, so it can be that such fire can be extinguished by using some sprinkler balls that the drones may, so if it is at 7th floor, so the drone may come to that floor, and through that, so these certain balls are there which can extinguish the fire. So it will throw such a thing at that after it has been commanded by the control center, okay. And once, so basically, once it has identified, it has informed this, it comes to that location, and then what is the actuation here is that the sprinkler, if you are, let's say, thinking instead of doing it through a drone, let's say you are doing it in a particular section in the room itself, okay. So automatically it's happening. So heat has been sensed, it has been informed to this command center. So it's an automated command center, let's say in your home, okay. And it initiates the sprinkling system, okay. That sprinkler will turn on, okay, and put out that flame, okay, automatically. So this whole thing can happen, can be configured even in a, is someone asking a question? Mr. Ramesh Babu, I think, trying to ask something. I see him speaking, but I can't hear. Okay, I continue. So this whole framework of having a detecting some heat, commanding it to the control center, it may be based either in the house or locally, which is monitoring multiple such frameworks, some such apartments, and initiating the counter action, that is sprinkling and closing out this fire, let's say. And that device which does this is an actuator, okay. Because sensor you typically understand, okay, it will sense something, but actuation is the one which will turn on or off a device, okay. So you know a valve, okay, you open the kitchen's tap, let's say, okay. So that opening of that kitchen tap, that is also a actuator, it is a valve, it opens, and then so water flow is there till the tap, right? But you are not getting the water, you get it only when you open it. So that is actuation, okay. So here actuation and sensor together form part of this. Typically all IoT frameworks have both actuators and sensors, typically, okay. All right, so with this idea, because sensors are typically understood, actuators are not that well understood always, so it was needed to bring in and motivate the reasoning why actuators in the IoT framework are important. Okay, now at the outline, when I was talking about the topics that I would be talking today, I spoke to you about that I will talk about flow compensation or flow manipulation on an aircraft's wing, okay, to ensure that the aircraft will not crash. Now, this kind of activity can be done through IoT framework. You may have multiple such devices, such systems. Okay, there can be different drones which may have them. Okay, they can be larger drones. Means when we talk about drones, you should not think that they are only these quadcopters which have rotating wings. There can be wings. There can be such. There are such drones which have both the rotating wings and also the traditional. This is our fixed wing setup. This is a NACA Wing 9 model. Okay, so and such aircrafts or such quadcopters are called biplane quadcopter. That is, they have the fixed wing section also and also the rotating wings. Okay, so in that, the fixed wing section is the one which controls the aerodynamic flow. Okay, and so that section I'm going to talk about now, where we are using something called a synthetic jet actuator. So this is also an actuator. Okay, and how it operates is that there is a cavity. Okay, this is the cavity, actuator's cavity. This is outside. There is a small orifice. Okay, so this top section is outside the actuator. This is the cavity, and here below that there is a vibrating diaphragm. Okay, connected. Now, when you and this plot and this figure and this figure, A and B, they are talking about two different half cycles of a sinusoidal signal which will be applied to this surface. So what is it? Is that we apply a sinusoidal signal, typically a 5-volt signal, okay, to this cavity. Okay, on one side there is this vibrating diaphragm, piezoelectric material, and on the other side there is an orifice. Okay, and this is between the orifice and the vibrating diaphragm, there is a cavity. So when you apply a sinusoidal signal of 5 volt, okay, what will happen is, in the first half cycle, at the rising edge of the rising edge of the sinusoidal wave, sinusoidal signal, the piezoelectric material is acted upon by that signal. It pushes the air outside this cavity. Okay. Why? Because the volume is reduced by the action of this sinusoidal signal on this piezoelectric material. So volume of this cavity is reduced. So as a result, air has to come out. Okay. So that air comes out in the form of a vortex. So you think about this vortex, this one pair and this another pair, they just sit on either side of this cavity. Okay, this happens in the first half cycle. In the second half cycle, what will happen is that air will come in, okay, through this. Air will come in. How much air will come in? Same amount of air that went out in the first half cycle. Okay. So overall, in the entire complete sine wave, means first half cycle and the second half cycle, over the entire full cycle, the amount of air that came in, same amount of air went out. So that is why this device is called zero net mass device. Then zero net mass. So what happened over entire full cycle, air came in, air went out and same amount of air came in. So why do we do something like where it came in and went out, or it went out and came in? The amount of mass overall is zero. Okay. But so mass is zero overall, but momentum is not zero. How is it? Let us see. So in the third half cycle, what will happen? Again, air will, because it's just a 5 volt AC, right? So you give 5 volt, one pair of vortex comes out. In the second half cycle, air comes in. In the third half cycle, again, pair of vortex should come out, right? So, but one difference between the first half cycle and the third half cycle is that In the first half cycle, nothing was outside in terms of activity from the cavity. So pair of vortex just went out and sat here. But in the third half cycle, when air is coming out, the problem is that pair of vortex is sitting here, and this is happening very fast. Okay, so it's like, when you smoke, there is some, these vortices come out, right, and they sustain for some time, for few cycles, and then it is destroyed, right? So same thing is happening here. So if it is done, if it is at a certain frequency based on the cavity dimensions and the orifice size and the sinusoidal signal, if everything is done properly synchronized, then what will happen? In the third half cycle, another pair of vortex will come. What it will do, instead of destroying this, it will simply push the previous half cycle. That is, so these two are from the first half cycle, and the vortices from the third half cycle is now seated here. Okay. So you are having two pair of vortices, one created by the first half cycle and the other created by the third half cycle. In the fourth half cycle, what will happen? Again, same amount of air will come in. So second half cycle and fourth half cycle are represented here. First half cycle and third half cycle are represented here. Like this, in the fifth half cycle, what will happen? This will get pushed here. Okay, so these two will represent the first half cycle. This one will be for the third half cycle, and the fifth one will be seated here. So like this, over several full cycles, means generally for an aircraft about 8 to 10 full cycles, what will happen is you will get a train of such vortices. So this train of vortices is called the synthetic jet. Okay. So now this jet of air, if it is interacting with the flow of air on the aircraft wing, okay, if you deploy these synthetic jets in these regions of this fighter aircraft, what will happen is these flow which are coming out can rearrange the flow of the air on the aircraft surface. So as a result, the closed recirculation matlab the flow will, instead of getting broken when the angle of attack keeps increasing, okay, if you increase the angle of attack, then the flow gets detached from the surface. As a result, aircraft crashes, right? But because of this jet, you can reattach that flow for some more time. Okay, so you now retain the pressure difference, okay, by this action. As a result, the aircraft will not crash for some more. You can increase the angle of attack without causing the aircraft to crash. Okay, and you can monitor all these things through the IoT framework. For multiple of such aircrafts, you can monitor which one needs actuation right now. Because why this is very good? Because similar to this here, when will it get actuated? When it will be told that there is fire, okay, in some sense, right? So it is not always you are sprinkling in your home, then there will be flood. So you are sprinkling only when the control command center told that now there is a higher temperature like this. Same thing even in the aircraft. So only when you apply this sinusoidal signal, vortexes will come out. If you don't want flow rearrangement right now, you don't give sinusoidal signal. Neither vortex will come out like this, nor they will go out, nor vortex will come out of this cavity, or nor air will come inside the cavity like this. In every half cycle, this motion, this interchangeable thing will not happen if you don't change the volume of the cavity by applying the sinusoidal signal. So in a IoT framework, this is always a reactionary, the same as here. When the event happens, the actuator turns on. Similarly, event here is that I want to increase the flow attachment on the surface because my angle by lift force is reducing. Okay, it will soon crash if I don't do it. Okay, so the event, so when you are told by the command center that you have to now activate so many of these jets such that flow attachment will happen on the surface of the aircraft. So the actuator reacts to that command and performs the action. Okay, so now some little bit of all this story is fine, but little bit of mathematics will be there. After all, we are engineers. So here, this is any system. Okay. Here right now I'm giving you I was giving you an aircraft example, but this can be any system. Okay. This K which you see over here is the sensor gain. In any feedback system, there is this sensor gain over here. Okay. So sensors and actuators are being depicted in this mathematical block diagram. This is simply a dynamic system. Okay. Any dynamic system, if it is having linear dynamics, we can always represent it using this state space formulation. Okay. This is a representation for our linear system. U is the input which is acting here. X is the state of this system. Okay. And Y is the output. And I can do state feedback. In that case, sensor gain is over here. This N dot that you see is our actuator. Okay. So it is like the kitchen sink. Okay. Kitchen knob for the flow of water. So water is, so you think about the same thing here. This is, let's say, your kitchen tap. Okay. The entire operation of this pipe flow, everything, how it operates, everything like that. Now the input is you are getting, when you open this tap, okay, this is the dynamics of this valve. Okay. So when you give it this information that now you open if you can physically do or use some robot to open the tap. So that signal you are giving here. This can be the force of the water that is there. That is now getting acted onto your system. So what is happening is, unless you open the tap, this is not there. Okay. So this is what actuator is doing. Any actuator, just like the synthetic jet actuator, output is what in the aircraft case, that is the lift force that will be created on the surface of the wing. Okay. So that was U. Okay. Output means output of the actuator, which is the input of the system. Okay. So the terminology you have to understand a little bit like this. So anyways, this is the actuator. This is your sensor gain. Okay. So actuator is seated in the input forward path. Sensor is typically seated in the output path. Okay. Or the feedback path. Now this actuator can have some uncertainties. I told you at the very beginning of this talk that there can be uncertainties in our actuator. It can change, some properties of this may change. So under that condition, how will we handle it? And I spoke about this inverse concept. So this inverse is nothing but a mathematical inverse of my actuator function. Okay. And that is what I am showing over here. So this synthetic jet actuator, it has been found, we have seen through different data-based study, is that when I have V for the synthetic jet is the sinusoidal input signal. Okay, U is the deflection that it will create on the aircraft wing or the lift force. Okay, and we found a relationship like this, where θ1 star and θ2 star are parameters, are some values that change under different conditions, typically change with the angle of aircraft of the wing, of the angle of attack of the aircraft. So angle of attack is what typically it's a state of the system. And so this is very interesting, is that the actuator dynamics are affected by the state of the system. And so this actually becomes a signal dependent uncertainty. Anyways, the uncertainty is only in two different parameters of this system. That means if I apply V, I am supposed to get U, right? But that I will get always, it's like saying that the valve kabhi pani kabhi kam aa raha hai. Okay, you have opened at the same angle, but you are getting a different amount of water flow. Okay, the flow rate is different. That can happen due to two reasons. One is that the input itself is slow. The other is there can be some rusting mechanism, something has happened in the actuator itself. So I am now talking about the thing that is that something change has happened in the actuator itself, which is causing that flow change, right? So that change which has happened in the actuator can be because these parameters have changed, okay? Because of whatever reason, maybe there is some tap, the orifice has narrowed down because of some rusting, something has got stuck, anything may be the case. Anyways, this is represented by this function like this. Now, I want to compensate this, means irrespective of that change, I want the same amount of flow, water flow, let's say, okay? So what I have to do, I have to compensate it, and for this, I come up with the inverse function of this, okay? Inverse function of this function is given like this, okay? This I call as the adaptive inverse. Why it is the inverse function? Because if you simply write inverse means here the output is U. Output means output of the actuator. I'm not talking about the output of this system, which is Y. Okay. Output is U. V is the input, right? When I say invert this function, now if I was purely doing mathematical inverse, okay, when I invert this function, what should happen is U should be the input and V should be the output. That is the meaning of inverting a function, mathematical function. So if I want to invert this, I should write V on this side and U should be on this side. So if I do that manipulation, okay, where such that V will come here and U will come there, exactly it is like this. Okay, so what you will get if you manipulate this, if you bring it to the left hand side and this to the right hand side, you will get V is equal to theta star. Okay, this is slightly different. I will tell you what am I doing here. But if I invert this function, what will I get? I will get V is equal to theta 1 star by theta 2 star minus U. Okay, so basically if I take theta 1 star by V on this side and then say the theta 2 star minus U and then do the inversion, I will get V is equal to theta 1 star by theta 2 star minus U. Okay, so in a mathematical requirement, that would have been enough, over. Okay, inversion of function is over. But in any physical representation, I need to, so this is the actuator, this is the inverse. So inverse is what, like I said, theta 1 star by theta 2 star minus U. Okay, but now U is here, I don't have U here. I have to provide that U. Okay, so that U which I have to give to this input, okay, is, I'm calling it as UD or U desired, okay, because exactly that U I don't have here, okay, and theta 1 star and theta 2 star are to be estimated by this, okay. Ideally, I will have theta 1 T will be equal to theta 1 star and theta 2 T will be equal to theta 2 star and UD will be equal to U. That is if the inversion is perfect, okay. But in the beginning, it may not be, okay. Asymptotically, it may be. So I am designing an estimator of this theta T, estimated theta T of the theta star. So basically theta 1 T is estimating theta 1 star and theta 2 T is estimating theta 2 star. And UD is the desired signal. This I simply, in a linear system, I simply say UD is equal to minus Kx plus R. R is the reference signal which is coming from outside. So UD for a linear system is simply state feedback. UD is minus Kx plus R. So anyways, this is my inverse function. Now objective is, ideally, I want U to become like UD. So the control error, that is called control error, U minus UD, I want it to be equal to 0. Okay. So I find the control error, U minus UD, I get representation like this. Okay. That means I get U in this way. Okay. This tells me some things, that if my theta 1 becomes theta 1 star, okay. Okay, this actually, this is a typo, U minus UD. This equation is for U minus UD. Okay, U, this is correct actually, but when I do some more manipulation, I get U minus UD equal to this. Okay, so that is called the control error. Now, this tells me that when theta 1, if my estimation is perfect, then what will happen? This goes to 0, this also goes to 0. So u minus ud becomes 0. Okay, and that means what is the meaning of u minus ud becoming 0? Means my inversion is perfect. So u minus ud, that is the desired u, is actually, because that's why I call it desired input. This is input to the system and this is desired input. I want it to be u, but I may not get it at all times. Okay, but asymptotically, when θ1t becomes θ1 star and θ2t becomes θ2 star, this will become, this equation will become u minus ud will become 0. That means u will be equal to ud. Okay. So anyways, if I do this manipulation on my feedback control system, that is x dot is equal to ax plus bu, and in place of u, if I substitute this, I will get this equation as my system. Okay. Now, similar to this, if I create another reference system where there is no uncertainty, that is like the autopilot. Okay, you have an autopilot. Your autopilot, you want, what is an autopilot? Basically, you say na, matlab hum aisa sochte hain ki autopilot is there, so we say that the aircraft is running on autopilot. Means what? The pilot doesn't have to do anything. It is similar concept to this cruise control. I hope you are familiar with cruise control. Cruise control is there in some cars. Okay, at least in US and Europe, almost every other car will have cruise control, because you are driving on interstate highways and where without putting your feet, you are just monitoring or just managing the steering wheel. You are not pressing your feet on the accelerator or the brake, and the car is moving at a constant speed. So what is cruise control? It's a supervisory control. Basically, I can explain from this, and for the moment you forget about these two things. You simply think about, this is your car, okay, and you just think about a control action here, the driver. Okay, now you are telling the car to go at 65 km/h, let's say. Okay, if you want to go at 65 km/h, if you don't have cruise control, what do you have to do? You have to press your feet on the accelerator, and if it goes more than 65, you have to slow down, give up your feet a little bit, press it. Also, you have to keep doing this continuously, and still you cannot exactly get 65. So cruise control, what it does is that it finds out what is the error. You are desiring to go at a speed of 65 km/h. What is the error right now? Okay. As soon as it reaches 65, what it does is it fixes the speed of the vehicle at that. So it presses the accelerator at that angle without you requiring to press anything. And in fact, you should not press the feet on the accelerator anymore after you have pressed the cruise control button. So once you have pressed the cruise control button, now the supervisory control has taken over. Okay. When you will come out of that supervisory control, when you press your feet on brake or accelerator again. Okay. If any danger has suddenly happened, you just press the feet on the brake, it will stop. You will come out of the supervisory control. So that is cruise control. If you press that, it will go at, the vehicle will start moving at a fixed speed. Okay. So the reference system is like the cruise control. You want to go at that, so that is your supervisory control. This doesn't have any uncertainty. So we compare it with this system and make sure that, and this part I will not, maybe for the audience of this thing, how we exactly mathematically do it, this proof is there. Okay, those who are interested may go deeper into this, but I will take you to ultimately what is happening. Okay, so basically, this is my error system. So error means this minus this, means x, error E is equal to x minus xm. Okay, so objective is what? That, and this I should explain to you. What is happening is that I will choose my this gain K, okay, in such a way that I will have some update laws for this, okay, some ordinary differential equations which will update my theta 1t and theta 2t in terms such that over time they will become like theta 1 star and theta 2 star, okay. So I'll update these adaptive laws such that all my closed loop signals are bounded, and this happens. This happening means what? My states of my system is now behaving as the states of the reference system. So that means I am achieving, if I want to hit a target, enemy's target, okay, I need to come very close. My missile should come very close to that enemy's target, right? I have to configure such that the error is very less. And at that time, if I blow up my missile, the enemy's aircraft will get destroyed. So this error has to be less. It mathematically, let's say, okay, it at infinite time, and in terms of different applications, that time is different, okay. In a missile launch and hit enemy target, it can be in few minutes, okay. So it depends, but the objective is that my system should become like the reference system over time, asymptotically, okay. So this whole thing is represented over here. This is my plant, okay. This is my controller. Normally, controller does not change with time, okay. If you take any fixed control system, it is there, it is working. If anything changes in this system, it is still trying to control the original mathematical system, right? But whenever we have uncertainties, because the system itself is changing because of the uncertainty, we have to adjust our controller, okay? And that is what is called adaptive control. So we adjust the controller because the system is changing using some update laws, and we compare that with a reference system or a autopilot. Okay, so we find the error between our system and the reference system. Okay, and that error we use in our update process. Okay, so that ultimately the error will go to 0. Okay, but the controller has to appropriately change for that to happen. Okay, so we make sure that the controller changes based on these update laws. Okay, so that is, I told you, I'll be speaking about the model reference adaptive control. So here there is a system, there is a model which is a reference of this system. I want my system to behave like this reference system. Asymptotically, it will happen when the error will go to 0. So I take that error, update my adaptive laws, and adjust my controller accordingly, such that this will happen. Anyways, this part is shown for a generalized first order system. I will skip this part so that, but it is available for those who want to understand this mathematical part at a deeper level. Let me now come to the artificial pancreas problem, where the same actuator and sensor framework is being used on an IoT platform. So I told you, in fact, I indicated to you that right now, this is in research phase, a complete closed loop. See, you have insulin deficiency, you take a insulin tablet, that is open loop control. Means there is no feedback. You have, it has been diagnosed by expert that you are having insulin deficiency. You provide regular inputs to that system through an insulin tablet or some injection, something like that. That is open loop. In closed loop, what is happening is that the artificial pancreas is there. It will continuously monitor and it will insert the certain amount of insulin into the bloodstream appropriately. On some days, it may do 50, 60 times. On some other days, when you are more regulated in your food habit, it may do 4 or 5 times. So it's closed loop. It can do at any time of the day, irrespective. Okay, but it is very risky also, because what if it does some calculations wrong it kill the patient before they can get any urgent medical attention. So typically what is done or what is envisaged that what will happen is what we call as the semi-automatic pancreas. Okay. So this semi-automatic means it is not fully automatic, means we don't, we have the artificial pancreas, we will be activating it, but it will not be given full control, okay, just for the safety of the patient. So how this semi-automatic pancreas works, there is an insulin pump, okay, which is the actuator, okay, and a glucose sensor. So we are having both the glucose sensor. Why glucose sensor is required? Because I must know what is the glucose level, okay, so I must sense the current glucose level in the patient, okay, so for that I have a glucose sensor, and an insulin pump is required to actuate this action of inserting the insulin, okay. So how does it do? So I have this glucose level monitor, okay. This sensor, what it does, it sends the current sugar level every 5 minutes, okay. Why we do every 5 minutes? Why not every second? Because if you do very, very frequently all these things, you will consume a lot of energy, the battery will exhaust very quickly, and so it will not be very practically usable. Okay, every day you will have to change the battery, or maybe 2 times a day, something like that. So typically it seems for the bulk of the patients requiring artificial pancreas, okay, the time, an appropriate optimal time is that the sensor can be configured to send the information of the blood sugar level every 5 minutes. Okay, so there will be a control algorithm which will be fed this information. Okay, and so this is one side of the story, because thing is that it is sending, but the thing is, whenever we have some food, okay, that is considered in the sense of artificial pancreas, from the perspective of artificial pancreas, it is a disturbance. Okay. Now, why it is a disturbance? Because it creates, whenever we eat some food, it creates a new dynamics to the blood sugar level. Okay. Because insulin, whenever we eat something, basically the body has been designed by the creator in such a way that food is supposed to be digested. So there has to be all the parts which are required to digest it, all the things like secretion of bile, okay, this monitoring how much the blood sugar level is there. If the pancreas is working fine, then all these things will happen. Okay. So, but when there is any deficiency, then this has to be monitored, okay, for our artificial pancreas. So whenever you are eating something, in our semi-automatic, we call it semi-automatic because we are asking the patient to enter the information about that food. Okay. So that, because the most major way of, or I should say typically the only thing that where closed loop fails is that, or may fail and cause fatal damage to the patient, is that the amount of food intake may be very random for the person. So unless we monitor this and ask the patient to enter information, patient or the caregiver or the doctor, whoever is, or the nurse who is checking on the patient, to enter the carbohydrate details and all. Okay, it's written carbohydrate here, but other information also need to be put to the control algorithm. So the control algorithm gets information about the sugar level from automatic. This part is automatic. Okay, you don't have to do anything, and here you have to enter this information. Okay, so the control algorithm, what it do, so that's why semi-automatic, not okay. It is not that you give the food and this will identify from the food what it will be. You will enter. Okay, so and then what does the control algorithm do? It decides and controls the basal insulin level every 5 minutes. Okay, so because this sensor information is every 5 minutes. Okay, in that time there may or may not be any food, but if there is any food intake in between those a particular 5-minute level, okay, then that information is to be fed. Okay, this may not happen all the time. I hope it is not happening all the time, right? Because it is happening only when we eat something, but this is happening every 5 minutes. So this information, it decides and controls the basal insulin level delivery, how much is to be given every 5 minutes, and it controls and returns the insulin due to the meal. Okay, how much is due to the meal, the difference. Okay, why it is required? Because sometimes the amount of insulin that is returned is not just due to the food. Okay, it is due to our body's ability. Suddenly today it has happened, let's say in that patient, that the body is not reacting well to the existing thresholds that have been set. Okay, so that's why that information is also, so in two parts, how much is the contribution from the food and how much is the natural contribution happening. Okay, so all this information is fed to us, is provided to us. Okay, so this is our IoT framework, semi-automatic artificial pancreas. So how it typically works, I told you that there is this food meal disturbance, right? So that is represented in this last equation. This one, so this is a Bergman type 1 diabetes mellitus model. Okay, there are 4 ordinary differential equations. I would like to explain to you what each of them mean. X1 is most important for us because X1 represents the blood glucose concentration. Okay, what is the glucose concentration in the blood, in the bloodstream? Basically, this is a coupled tank. In many of the control labs, if you are from electrical or even chemical engineering departments, you typically have a coupled tank in your control lab, okay, or even in the process industry kind of lab. In a chemical department also you will have. This is also a coupled tank. This means not just this model, are the insulin and glucose are 2 different tanks in our, conceptually are at least 2 different tanks in our body. So this X1 is the blood glucose concentration. X2 is the remote insulin concentration. Okay, remotely what is available. X3 is the plasma insulin concentration. Okay, so in the plasma, what is the insulin? Okay, and outside, remotely, what is the insulin? Okay, these 2. So first, the X2, this dynamics is the remote insulin concentration. This is the plasma insulin concentration. And the last one is the meal disturbance. What will happen, at what rate this will change because of the meal that you took. Okay, and this GB is the basal value of the means baseline value of the glucose concentration, and IB is the basal value of the insulin concentration. So once you have this, you can see that actually this is almost linear except that this term is there. So X1 cross X2 or multiplied times X2. So this is a nonlinear system. Okay, and we have identified 5 parameters which may change at different extents of time. Okay, so similar to the synthetic jet compensator where we had theta 1 star and theta 2 star, here we have 5 uncertain parameters. So naturally, we will have a reference system, okay, where these parameters in this case are known, okay. So difference between that problem and this one is that there are 5 uncertain parameters and 4 ordinary differential equations. So, but conceptually, this is working similar to that same model. I have a patient, okay. So there it was an aircraft. Now here it is a patient. Okay, this is a human beings, dynamics in the body, what is happening. Okay, so this is the input. This is the state, at what level it is right now. Okay, so all of these, all 4 of them are represented here. That is why I have written Xi. Okay, I compare it to a reference model. Okay, so reference model has states Xi hat, X1 hat, X2 hat, X3 hat, Xn, X4 hat. So they are represented over here. The objective is to reduce the error, make it 0 if possible. What does it mean? It means that my system is becoming like the reference system. Okay, so that is ideal, because this is what is a patient whose diabetes is controlled, or desired dynamics is given over here, right? So that error, similarly in the previous case also, we had put that error through the adaptive update laws, okay, and used it in our control law. Okay, so same thing you can see over here. We use the error to the adaptive law, and that controls the, or updates the controller accordingly. So same thing is happening over here, conceptually at least similar. Okay, and this is our reference signal R. So when we do this, now the mathematics or the proof of it may be more involved, okay, and probably suitable only for someone who is interested to work further in this kind of topic. But I would like to show you what happens, what kind of results we get, and how we are able to control diabetes, or how this semi-automatic artificial pancreas will actually work. So to do this, let me show you these. So some gains are chosen. These are the initial conditions. Okay, what is the initially? What is the initially means before my semi-automatic artificial pancreas comes into play? What are the different states? Okay, how much I have eaten? What is the plasma glucose concentration? What is the remote insulin level? And what is the basal insulin value? Okay, and these parameters that I have taken, because this is after all a physical system, okay, our body, we know what will be the nominal parameters. We know in what range they may change, because remember I said that the parameters may change. Now if it is, let's say if a particular parameter is 2 and next moment it becomes 20,000, you cannot control such a system, right? It should be realistic. It should be, it is, because it cannot change like that. Okay, any physical system will change within some possible margin of errors and things like that. So we always, for anything physical system, any physical system, we always the parameters will lie. Okay, they may change, but within this range. Okay, so we know this. So applying this, we get, applying this adaptive control of this patient, we get this kind of result. And this is what I would like to now explain to you properly, why it is significant. Okay. See, there are 2 terms which are familiar, which you need to be familiar to understand the insulin deficiency caused type 1 diabetes mellitus issue. One is hyperglycemia. Hyperglycemia means if your blood glucose level is more than 180 mg per dl, okay, daily, okay, milligram per dl. If it is more than 180 mg per dl, even when you have eaten food, please hear my statement with all these words properly. If you have eaten food at least 2 hours before, and if we are measuring, checking right now, And if the blood sugar level is still more than 180 mg per dl, then you are hyperglycemic. Okay, this was 180 level is shown over here. Okay, and if you are if you have eaten, let's say 2 hours before, and your hyperglycemia or your sugar level is less than 50 mg per dl, then it is called hypoglycemic. Among these, this hypoglycemic is the most fatal. If your sugar level, and it is counterintuitive, we think that only if it is more, it is very dangerous. In hypoglycemic situation, you will not immediately, no, the patient will not immediately die. Okay, there will be enough time to treat that person if the sugar level goes up, unless it goes 1000 or something. But, maybe patient will not survive in that case. But hypoglycemia is the situation where it is very dangerous. Fatal immediate death happens if it goes below 50. Okay. So anyways, range should be between 50 and 180. But at the same time, why it is for as a control person, why it is important? I should not try to reduce, this is very important, I should not try to reduce this sugar level very fast. Okay, so it is not that if it comes down very quickly, it is good. No, because if it comes down very quickly, there is a possibility that it may go under 50 mg per day. Then it is very risky. So your control should be in such a way that it comes down within 2.5 hours. It enters into 180 mg per dl within 2.5 hours. Okay, it should not, because anyways the patient is diabetic. You cannot make him with artificial pancreas. You cannot make him cured from diabetes in one day. If you try to do very aggressive control on this, okay, there are control algorithms which can do very aggressive control, but then there are chances that under certain conditions, you may undershoot this 50 level. And if it lasts for 30 minutes or 1 hour, the patient will die. So this slow process of reduction is important. So objective is that it should come within 150 minutes, matlab within 2.5 hours, it should come below 180 mg per dl. And that has happened. So that means the control action is successful. Okay, this is the insulin level, this is the sugar level, this is insulin level, and these are interesting, important. Is that the error signals? I told you the error signal means this xi minus xi hat, means reference system states. What are the states? States are after all glucose concentration, remote insulin, plasma insulin, and meal disturbance. Between this model where there is uncertain parameter and the reference model, what we see is that the control is such that the errors have all gone to zero. They have not happened immediately. Okay, they've taken some time, and in around 100 minutes or so, they've all gone to zero. For example, this insulin concentration has not gone to zero very quickly. It has taken even more time, maybe 200-250 seconds it has taken to become zero, but it has not gone high. So the difference is not very high. Each of them have taken different amounts of time. Okay, for example, the meal disturbance is zero in around 80 or 90 seconds. Okay, E3 has taken more time, but ultimately all of them have gone to zero. Okay, so this is also a success. Parameter will not, the tracking errors are this. So the system, our system has become like the reference system, but you see the parameters go to some fixed value. They don't go to the same exact value as the reference system. Okay, because we have only updated the parameters as per the estimate. But that is fine as long as we get the tracking errors to go to zero. That means the patient is safe while using this artificial pancreas. So related to this, if there are questions, I would like to address them. And any part where I have some time, any part where you would like me to, if anyone likes me to go through some of the mathematics, that also we can do. And questions I would like to take. And these are some information about if you are working in any field related to infrastructure, the IoT, the ICT infrastructure, these are all part of infrastructure work or control. Okay, then we have a book series that I edit with two other researchers, Professor Swine from New Zealand and Professor Alexandra from Bulgaria. And also I am an associate editor in IEEE Access. So for both these, I invite submissions from researchers, and I'm open to questions, related questions, or any questions for that matter from the attendees.
Participants, if you have any questions, you can please unmute yourself and ask.
If you have questions, you can also put in the chat box. I can.
Priyanka, you can ask students if they have any questions, they can put it on chat box.
No, sir. Participants, if you have any questions, you can please put it on the chat box. Sir, there is a question.
When this semi-automatic pancreas works, how can it be? When it works, how can it be replaced? Do you mean when it doesn't work, how can it be replaced? I think that's what you mean. To him, yeah. So yeah, when it doesn't work, how can it be replaced? So basically, let us. So basically, if you are, say, everything is about thresholds. You have the sensor providing you information about the glucose level right now, okay? And you are entering the information about the food you are taking, okay? Now, if you have gone, let's say, let us look at this, yeah. If at any instant, okay, any instant means you have provided this information and these values, so initially they will be high. It is expected, there is no problem. Okay, if you, if after, because, and you notice that it increases. It is normal that when you eat some food, okay, this is, so 0 is the time at which you have eaten some food, okay. And these, so this elapsed, this time means the time elapsed after you have eaten food. So basically, when we say that the blood sugar level is, let's say at this level, 250, that is after 100 minutes of eating food, okay. So that means immediately after you have eaten food, it increases and then it goes to 300, 400, this kind of thing is fine. You have, so some threshold will be there. If it goes instead of this, if it was 800 or 900, then there is a cause for concern. So the threshold will be there. It will indicate, okay, every single part of this mechanism, okay, wherever you have, for example, let us talk about this. Wherever you are observing at every single minute, right? So if it crosses, so this is reasonable value. If it crosses 600, 700, 800, okay, very fast, okay, that is not good for the patient. So you can, supervisory control can stop the operation of this artificial pancreas. Similarly, if it doesn't enter this band within 150 minutes, here it is entered, right? If it doesn't enter in this band, matlab, if after 150 minutes also it is more than 200, 250, something like that. And if the rate of decrease is not there, if it has stabilized, then it is a red signal again. So such thresholds can be built into the controller to ensure that it is working properly. Now, if for any reason it is very much away from the desired or expected outcome, let's say more than 10 or 15% different from this, okay, then you can easily stop this activation of, you can easily stop this basal insulin delivery. This delivery happens only when every 5 minutes, whether it will happen or not, it depends on the current levels. Okay. If it has not crossed the threshold, you will not do this delivery. If something goes wrong in the sensor, then some erroneous value will come. Okay. If that value is unexpected beyond the threshold, then again it will not, this delivery will not happen. So it happens only if you have not, if the rate of convergence is not proper and beyond 10 or 15% if it is, then only you will do. If it is beyond that, you will stop the operation and then go back to manual for some time till it is fixed, manual delivery of insulin. I hope that answers your question. If it's not, please ask any clarification. Okay. So security will be an issue. If so, what preventive measures can be taken? Security means, see, if it has gone beyond the threshold, anyways, artificial pancreas is very useful in those patients where the delivery of insulin is required to be very frequent. If it is only once or twice you need, then in a day, then the insulin tablet injection, those are there. But if it is more, then what will happen is you will have to be admitted and given under monitoring continuously. You have to be monitored, and so then that your life is in the hospital bed. So for such situations where the insulin delivery is frequent, let's say maybe 4, 5, 6 times in a day, in such situations it is convenient. So it is a device that has to be on your, please understand, it is a device that has to be on your body all the time. Okay, so it is not desired if someone is having, if someone's sugar level can be controlled with one insulin tablet in a day, why he will put artificial pancreas? So security means a person who is having artificial pancreas is already someone who is a high level sugar, his sugar level or the system is not normal right now, or far away from normal actually. So he needs to be monitored anyways. And that is why the IoT framework is required. His levels, all these data have to be back and forth available, and his caregivers have to check. Only thing is, with this, he can be at home. Otherwise, he has to be always in the hospital bed. Right? So that is the reason why this is. So it is not that it is not secured, and preventive measure is if in spite of it, it is not working, he has to be admitted in the hospital, and regular treatment, which is to be given for very high sugar level people, will be given to him. This device allows, bottom line, I'm still answering this question only, Tuhin's question. Bottom line is, this device helps one to live a reasonably independent life away from a direct medical care continuously all the time, simply by relying on some amount of automation. That's why semi-automatic, some amount of automation of insulin insertion in the bloodstream. Does that answer your question to him? Okay, so the next question is from Kavya Rusu. Nowadays, smart watches have SpO2 feature to check the oxygen level and give an alert to our phone for unusual level. How does it work in terms of IoT medical application? So yeah, that is true, but this SpO2 feature, and of course, I'm giving, this is like a sort of not fully a sort of a user perspective answer I'm giving, that SpO2 level, it has been seen, because now we are using oximeters and these smart watches that you are saying. First of all, most of the smart watches are not giving precise values. It is turned out to be not very this thing. Only those smart watches which actually have the circuitry that can give, that oximeter is having, okay, can actually give precise values. Because why I say this? Because it has shown simply with the orientation, for example, oximeter, okay, it has been seen that different, that the same patient in 10-15 minutes in different intervals of time is having very different SpO2 levels. Okay, so this is simply a incorrectly operating mechanism. Please understand that this oximeter and all these things are, and this is very relevant question, but the thing is that these semi-automatic artificial pancreas, oximeters, SpO2, the smart watches, everything is meant to give us, to provide us some ability to monitor our essential vital statistics, health statistics, while being away, means independently, without relying on a doctor to check all these things, right? But the thing is, there are very limitations of this. These sensors and these devices have not yet become so advanced that they can give precise values. And so you can, so answering your question, giving an alert for unusual level, I am not quite sure that today, for most of the devices that are available, this unusual level is reliable. I don't find them to be very reliable. Of course, you will, if you feel that your oxygen level is very low, or if means the device and you are feeling, if together it is, both are saying that it is low, then only it makes sense to, because sometimes oxygen level, even I have seen when I was fine and I am during lockdown, it is showing me 85, 86 also, but I was not feeling anything like this. Normally, the ICMR is saying that if it is less than 90, you have to be admitted. Okay, but I really feel that was an issue with the device. Sometimes it was showing 85, 86, and after half an hour, it is again showing 95, 96. So some of those means my answer to your first question is that the devices to be used for such IoT framework to give automated means, see, this can give, send a, for example, the IoT framework can be used to, through the smartwatch, they can be connected through a network in such a way that if my SpO2 level comes below 85, immediately a ambulance should come to my door, right? But if these sensors are not working well, or can we really at this stage with most of the smartwatches, can we really have a situation where we can make it automated that if it goes below 85, the ambulance will come? Then so many ambulances will come to our doors when actually it is not an emergency. So some steps in those direction is also required. So only if it is, so smartwatch for this, I'm not quite sure that it is giving consistent values. This IoT framework is applicable, I would say as of today, is applicable for, remotely monitoring old age home patients who are having all the advanced sensors and circuitry in the home. Okay, this is like a remote nursing home monitored by caregivers. In some developed countries, this provision is there. There, if the guy falls down also, his fall detection algorithms are there. He's being monitored. Okay, immediately care will come to his door. Okay, so for that, such advanced sensors and everything has to be there so that the alarm is not false. That is my summarized answer. Alarm has to be precise. Your second question, what kind of sensors has it been used here? Here means, you mean in which application? I think, see, the sensor that we are using for our artificial pancreas is sugar level sensor. Okay. Sensors I spoke to you about. Huh? Yes. You can type if it is. Hello.
Yes, sir.
Yeah, I just want to know what this. He has asked a question: what kind of sensors it been used here? But which application he is speaking? I just wanted to know. Yeah. Okay. All right. So if your question is answered, any other questions? Thanks, Kavya Rishi.
If anybody else is having any question, you may please ask by writing on the chat box. All right, so I don't think if now anybody is having any kind of question, inquiry in.
All right. Thank you for
Thank you.
attentive
you so much,
hearing.
sir.
Yeah.
Yeah,
Thank you.
so-
Thank you, everyone.
Yeah, thank you so much, sir, for coming and giving your precious time for us. And thank you a lot, sir.
Thank you. Bye.
Right, thank you. Dear participants, we will having a lunch break right now, and then we will meet again after the lunch break.
Abhishek sir? Abhishek sir?
Yes, ma'am.
Should we begin?
Just give me 2 minutes, ma'am, please.
Yes, sir.
Hello. Okay, I'm ready, but I think there is a 5-minute less. So if wish, I can start.
Yes, sir. I have formed in the group. Good afternoon, all participants. I welcome you all to the third session of today in our 1 week online ATAL AICT Faculty Development Program on IoT and its applications. Today among us, we have Abhishek Rawat sir. Dr. Abhishek Rawat sir received his Bachelor of Engineering in Electronics and Communication Engineering, Master of Technology in Microwave and MM, PhD in Smart Antenna Arrays. He has worked as Assistant Professor in Electronics and Communication Department at Samrat Ashok Technological Institute, Vidisha from 2003 to 2014. Currently, he is associated with the Institute of Infrastructure Technology Research and Management, Ahmedabad, as an assistant professor, Electrical and Computer Science Engineering Department. Dr. Rawat is also selected as a senior member IEEE and has published more than 70 articles in international journals, book chapters, national and international conference proceedings. He received the Young Scientist Award from MP Cost, Bhopal in 2007 and is involved in the field trials of the IRNSS Receiver of Space Application Center, SAC, ISRO, and published 4 Indian patents. 1 patent was also granted to him, and he is also the coordinator of Drone Center of IDSR and Electrical and Computer Science Engineering Department in IIT-RM. His research interest includes navigation systems, satellite communication, advanced communication system, and peripheral security. Sir, we are very thankful you took the time out to enhance our FDP with your presence and share your knowledge. We welcome you. Over to you, sir.
Thank you.
You have been made the yes, sir. You have been made the co-host, and you can share the screen.
Now, please confirm my screen is visible.
Yes, yes, sir. And you're audible. Quite clear.
Okay. First of all, thank you for inviting me to deliver this particular lecture. So my title of my today's lecture is Application of IoT in the Drones and the Regulations. As you know that IoT is one of the very hot cake nowadays, because with the help of IoT, we can connect a different type of objects. Okay. with the internet or with the embedded devices. And with the help of that, actually you can conduct a lot of processes and lot of tasks you can do automatically. So that is why from last 4 to 5 years we are getting a lot of attention on the IoTs. And one more thing which playing a very big role for the commercialization of IoT is the low cost computing. Earlier, the controller was very costly, but right now the cost of controller is reducing. So this low cost controller will help us to reduce the computing tasks. So that is the reason, because we are just getting a lot of attention on the IoTs. So here, these are the 5 points which is make the IoT possible. First is we have low cost and low power sensor technologies nowadays. So it is making our life simple. Second is connectivity. We can easily connect it with the help of Wi-Fi LANs, with the help of GSM cards, with the help of RF modules we can connect. So easily we can transfer your data from one point to the other points. The third is the cloud computing, that you can store the loads of data on the clouds. And with the help of machine learning and artificial intelligence, you can analyze this particular data. So I feel I think this is the 4th day. So till yet you are familiar more about the IoT. So I'm just focusing on the application part of the IoT, which I'm using in the drones. So we are involved in the drone operation from last 4 years, and without IoT, it is not possible to be conduct the drone operation. I think all of you are familiar with the drones. One thing is there, this is an interactive session. So anybody have any doubt, and if anybody want to get clarity, he can raise the things. Okay. So madam, please allow all the participants to keep on their mic. So if they have any doubts, he can interrupt me anytime.
No, sir.
Okay. So basically drone have a lot of attention nowadays also, as you have know the IoT with the IoTs. From last years, you know, one drone attack was happened in one of our Air Force station, and you know the lot of drones attack is going to be happen. One drone attack, they have killed Iraq's one of the generals. So a lot of things is going to happen about the drones, and even in India, the security agencies have a lot of problems because of drones. Because with the help of drones, they can easily commute from their material from one end to the other ends. So the beauty of the drone is that this is basically a remote pilot aircraft, and its size is low, its cost is also low, so it can easily move from one point to the other point. So we can easily send a few kilograms of payload from one point to the other point, and it is very difficult to detect. So right now the drone is going to be a lot of attention. Even in US and in European countries, they have got the permission to deliver the commercial material with the help of drone. Even 6 months back, the government of India is also allowed the delivery of our vaccines through the drones. So that particular things is also going to be operated as a pilot procedure, especially in the northeast states where the hilly areas will be there. So drone is also getting a lot of attention, but drone cannot be complete their operation without of IoT. So IoT is one of the very important part of drones. So first I will discuss the drones, and then I will discuss the application of drones and how the IoT will enable the drones to complete all these type of operations. So first thing is the PRS or US. So these are the two technical terms which you are listen many times. So RPS is remotely pilot aircraft systems, and US is unmanned aircraft systems. So these two terms is generally used, and generally these two terms is indicates you have some remotely pilots aircrafts. That means in that particular aircraft, your pilot will not on board. Okay, from with the help of some RF module, you are controlling that aircraft from some kind of the remote areas. The second terms is the autonomous aircraft. That means with the help of path planning, we will give the path to your aircraft, and aircraft will follow that particular path and land to the predefined areas. And third is the model aircraft. So model aircraft basically modeled for the specific operation. Generally, it is used in military services. Suppose suicidal drones, some drones is for the navigation of a particular area. So these type of things. but all these things comes under the condition of the PRS or US. Basically, we have 4 type of drone categories. The government of India and Department of Civil Aviation have subdivided these 4 classification. Even in abroad, this classification is a little bit changed, but in India, broadly, we will take these 4 classes. First is a very small, that is the 250 grams to 2 grams. Then small, that is 2 grams to 25 kg. Medium is 25 kg to 150 kg, and large is from 150 kg and more. So basically, if we just talk about the drone is not a fixed wing operation. So generally, very small and small, these 2 category will be there, and we again subdivided this particular category into the 4 other categories, which I will discuss in the later on class. So basically, different type of drones we have. Some is single rotor, then multi-rotor. Single rotor, you can know the helicopters, then multi-rotors, conventional drones, then the fixed wings drones, small aircraft. Okay, then fixed winged hybrid drones. That means it can also operate with the help of gasoline and with the batteries. Then other different classes will be there, and some reconnaissance type of drones will also be there. That is generally used for the military survey operations. So in this slide, you can find the anatomy of the drone. So basically, drone have the quadcopters. So first, you have a frame, then you need a motors, then you need a electronics speed controller, because you have to be control the speed of motor. Okay, so that you can move your drone forward, you can land your drone. Even sometime we have wind disturbances. So for the wind disturbances, we have to be anyways to counter the wind disturbances. This ESC play a very big role, and we have to be stabilize our drones. Then the most important thing is flight controllers. So in drones we don't have the pilots on board, so flight controller play a very big role. So he have to take their own decisions, and he have to be connected with your command centers. Then we have the propellers, of course, the radio transmitters. We need the batteries, electronics, power distribution cables, and we need the camera. So these are the some components which is we can onboard on the drones, and these are the I can say these are the some components which is always should be there on the drones. Without that drones will not be operated properly. So this is the one circuit diagram of the drones. So in this circuit diagram, you can find these are the 4 motors, and it is going to be connected with the ESC. ESC getting the power from the batteries, and battery and ESC is going to be connected with one receiver and controller. So in this way, it operates over there. So flight controller is just like a brain of your drone. So it will receive the signals from the RC receiver and send the signals to the transmitters, and it is also receive the signal from the Raspberry Pi. I think you are familiar with the controller Raspberry Pi. I hope all of you
Yes,
are
sir.
familiar with the Raspberry Pi controller.
Yes, sir. Yes, sir.
Okay, good. So Raspberry Pi 0 we are using right now for all these type of operations, because it is small and big weight. So some kind of the computational things which we have to do, so we can complete all these computational things on board on the drones. So this is the first frame. So in this frame, generally quadcopters, we have these 4 frames, but in generally we can take the hexa stable frames we can also use. Generally we will use the hexa when we have to be carry a big load, okay, or we have to be cover a long distance. One quadcopter octa-quad type frame will also be there when you need a very fast speed. So this third one, I think my pointer is visible to all of you. So this generally used when you are going for the high speed operations. Then the propellers. So generally we have the 3-degree pitch low propellers or the 5-degree pitch propellers. So these type of propellers, so we have to be either print on the carbon fiber, or with the help of 3D printing we can also print it out. Generally we will prefer the carbon fiber because they are low in weight, and they can handle the much load pressure over there. The second is the brushless motor. Brushless motor is one of the very important components of the drones, because in drone we have to give a very heavy thrust. Okay, and the power is also, we have the limited power because we are running all the operations with the help of, hello.
Excuse me, sir. Sir, screen is not moving. We are just seeing the first slide.
Oh, sorry, just I think there is some issue. I'm sharing my full screen. I think then it will be better. Now my full screen is visible.
No, sir, not right now.
Please confirm now it's visible.
No, sir. Yes, it has started.
Now it's visible.
Yes, sir. We are on brushless motors.
Okay. Sorry. So I just go back to these things. Thanks. So we have discussed this is the basic circuit diagrams, and we have discussed this is a block diagram of your drones. So in drones, with the help with flight controller, we also have a Raspberry Pi. So with the help of Raspberry Pi, we can conduct some of the key operation even on the on boards, and then we will send this information to our base station. So this is the frames. In this frame, this is the first frame. Four generally we will use for the low loads. If you have the high loads, then you will prefer this is hexa frames, and if you want to go for the very high speed, then you have to take the octa stable drones. Okay, so this is the propellers, and now we are on the brushless motors. So brushless motors generally light in weight, and they consume the low power, and they will provide the highest thrust levels. So on the almost all the drone operation, we will use this brushless type of motors over there. Then we have the electronics speed controller. This is one of the very important components, and here you can find it out. Generally, we have this red one is for the positive 7 to 26 volt, depending on the requirement, and this black one is ground, and this is this particular terms is the providing PWM. So with the help of pulse width modulation, you can control the amount of power which is going to deliver your brushless motor. Okay, and this brushless motor provide a thrust depending on that. Generally, lots of ESC is available in the market, but DJI or 3D the Parrot, which is the commercially make the drones, they will develop their own ESC, which is supposed to be more robust in operations. So basically, this ESC take the power from your battery and convert this battery power into the 3-phase AC supply, because your brushless motor is operate on the 3-phase supply. So this is one of the very important components. So whenever you will make your drones, don't compromise on the ESC. Then the flight controller. So right now we are using pick-stop controllers over here, but a lot of other controller will be there, just like heavy power KK 2.15. DJI NASA is also one good flight controller. Then Cube Orange is also one of the very nice flight controller. But if you have the funding problem, then I will recommend you the pick-stop. So pick-stop is a very cheap controller. You can just get it up in the 4,000 or 5,000 rupees. So as I have told you, it's just like a brain. So all the operation of the flight controller will be, all the operations of the drones will be conducted over here. So it collects the signals from the ESC, from the motors, from the GPS modules, communication module, and provides the interface about there. And even when we give the programming, then all these particular programs can also be stored on the pick-stop. I think all of you familiar. Pick-stop is basically a German startup. Okay, and the pick-stop is very vastly used for the low range operations. Of course, if you are going for some critical operations, drone operations, or applications, then the Cube is the best solutions over there. Then the battery is one of the very key components. Many persons is told our drones is fed on the very high altitude. Actually, drone is not fed on the high altitude. Battery is fed on the higher altitudes. Because batteries generally operate more than 0 degree temperatures. So you have to take care of a battery if you are working on the high altitude operations. And as the height is increases, the temperature is also going to be decreases. So that things we have to be take care. Generally, we will prefer the 2, 3, and 4S configurations. Now my slide is changing, visible. Battery slide is visible.
Yes, sir.
Okay. So 2, 3, and 4S configuration will be there. Generally, we are using the 3S configurations depending on there. And 8000 mAh is generally sufficient for the operation for 20-25 minutes. But if your operation is for the long time, then you can take the larger batteries. 5S and 6S voltage is also supported, but other this PICSOC and all these ESCs is more compatible for the 3S configuration. So generally, we will prefer the 3S configuration of the batteries. Then the power distribution board is one of the very important part for your drones. This basically distribute the power for all these things. Actually, we are getting the power from the batteries, and battery have to be give the power to the ESC, all 4 ESCs, then the voltage regulators. Okay, then it also have to give the power for the GPS modules, RF modules. So, and all their impedance is different. Okay, so basically the power distribution board match all this this particular load impedance, so that the maximum power proper power should be delivered for each and every devices. Then the receiver, which with the help of receiver, you can collect the information which you are coming from the drones. Then we need a camera. We can mount on the drones, but drone is generally movable platform. So your fixed camera cannot be work very nicely. So what we have to do, we have to use the gimbals. So with the help of gimbal, keep your camera stable so that you can transmit properly videos and take the picture properly over there. Some of the time, some cameras need their own antennas and FPG Googles. So with the help of this FPG Googles and antenna, they can directly transmit their videos to the base stations. So this is also one kind of the IoT modules which help us to be real-time calibrate the operation of the drones. Some of the times the GPS is not work properly. So with the help of this particular camera, your controller can take a decision and land it properly. Even GPS, I think you are familiar. It's a global positioning system, and right now we also have our own navigation modules that is known as the NAVIC or IRNSS. So right now we are using the GPS, but I am sure in next few months we will also test our modules with IRNSS or NAVIC. So with the help of GPS, we will get the latitude and longitude data. Because in drone operation and all different type of IoT related applications, the location is one of the very important things. And generally drone travel long distance, because air distance it's very easy to be covered very fastly. So with the help of GPS, we have to get it up the accurate position of the your drones. Generally, GPS is not a very accurate system for the drone operations. Every time when we check it out, 3 to 4 meter error will be there. So whenever you will perform any type of IoT application on the drones, always keep that particular chances of errors will be there, and always keep maintain the safe distances when you are moving your drones with the help of automatic mission planners. This gimbal actually absorb the shock and keep your camera in a one particular direction, so that you take a proper video and clarity will be there. So without gimbal, your drones will not be capable to perform the image processing operations. Then the most important transmit and receiving modules. Of course, your drones is operating on the air, so we need a very reliable mode of transmitter. So generally, we will get the 2 transmitting modules. One is working on the 2.4 gigahertz, and other is 5.1 gigahertz. So different modules is available on the market. You can make your own market. So generally, you can connect your drone with your laptop. Okay, so this is the one transmitting module will be there, and this is the manual module. So generally, we will not prefer this particular manual module for operations. We will prefer this particular PC based modules, because in PC we can exactly see the error of the GPS. So whenever you will put it up your drones, and when you check its location, you can identify, yes, your location is showing 1.5 meters away over there. So this generally we will prefer to be operate the drones with the help of your laptops. So this is the one assembly of drones. PICSOC, this is a buzzer connected. Here you can find it out. The battery is going to be connected with the power module. Power module is connected with the ESC. ESC is connected with the brushless motors. Okay. Then this is the transmitting and receiving modules. Generally, when you are connecting with your RF modules, so this is a one other communication module. My cursor is visible. My cursor.
Yes, sir.
Yeah, this is the manual modules. If you want to be manually operate, so you have to be do it. But when you are operating, want to be operate your with the help of laptop, then you need another telemetries. Okay, so these two different telemetries you can connect with the on the PICSOC. So these are the some assembled when you generally you have the two choices. Generally, most of the person purchase their own drones. DJI drones you can purchase, and Parrot you can purchase, but its cost is very high, and the low cost drones is not deliver which they commit in their advertisements. So always for the crucial operations we will assemble our own drones. So to assemble the drones we need the motors, propellers, flight controller, GPS modules, ESC, power ports. Then one important things we need, that is the obstacle avoidance sensor. So in case of any obstacle will be there, so this sensor will be activated. Then the gimbals, cameras, and batteries will be required. The rest of the things I have already discussed, but drone antenna is also one of the crucial part. But I think most of you from the CS module, so I'm not going in depth. The same thing is with the obstacle avoidance sensor. So basically, it's ultrasound sensor. So this sensor is put it up in all 4 directions. So this sensors will send the data to your flight controller, and flight controller take the decision. Now, one example I just want to be share with you. We fly one drones over here, and we are manually operating that particular drones, and all of a sudden, very high wind will started, and because of this particular wind effect, the drone will be goes away from our control range, and in few seconds it goes out of range of our transmitters. So we are all worried, where is drone it is. Then with the help of this particular downward ultrasonic obstacle sensors, when the transmitter, your controller will not receive the transmitter signals, it will goes on the downward ultrasound obstacle avoidance sensor mode. So all the sensors are activated, they will go down 1 feet by 1 feet, and it's landed around 2 kilometers away, and we recovered it. So this is one of the very important things which you have to be mounted on the assembled drone. Then the flight light you have to do, even from the DGCA rules you have to do it. You have to be put it up the joysticks. So this give the information to the controller about the movement of the drone, exact movement of the drones. Then you need a man remotes as well as the man camera on boards. So this is the drones which we have in our labs. Here you can find it out if it is visible. It is a D1. I think you are all of you have purchased. Whenever you purchase your car, you have to go for the ITO for the registration. So this drone is also registered in DGCA Sky, DG Sky board. So every drone which is more than 250 grams, and if you are doing the operation, even it's a research operations, you have to take the permission from the government. So this drone is registered, and its ID is D1. Okay, and even the drone operator also have to take the permission for the before the drone operations. So this drone we have assembled in our lab and lecture. So we have registered this particular drone in DGCA Sky, and our operators or our students is also registered over there. So whenever you will do any type of applications of IoT on the drones, always make sure your drone should be registered, and you also have to inform the local police station about your operations. And now I'm showing one video of assembly of the drones. Please confirm my screen is visible. Please confirm my
Yes,
screen.
sir. Yes, sir.
Yes, sir, it's visible.
And video is visible.
Yes, sir.
Good. So this is one small video so that you can get the idea how all this assembly is going. This is a ESC connected. This is a connection of brushless motor. बेटा सारे अलग अलग हैं क्या? सारे अलग अलग हैं इसमें ये जो फर्स्ट वीडियो होगा वो कैलिब्रेशन उसका वो ईएससी वगैरह का लास्ट में मोटर वगैरह these are four 1 to 3 These are the 4 connection of ESC. This is a power supply module. This is the top plate which will be mounted. And this is a flight controller. This one telemetry is for manual and other for your computer.
Admin login success ayyindi. Rectangle box lo unnai kada.
This is the connection of the telemetry. Now this is the complete assembly of controller and transceiver. And we are fixing the GPS modules. Now 4 ESC connected with the fixed soft. Then the battery connection. There is a connection of battery fixed soft. Now, I hope my voice and slide is clearly visible.
Yes, sir.
Clearly visible. Okay.
Yes.
So this is how we are calibrate the things, and I hope this video is properly visible to you all. So with the help of this video, you can understand how we are completing the assembly of the drones. So once the assembly is going to be completed, assembly is also taking around an hour time. Okay, we just skip the longer process, but most of the important processes we have completed. So if you are the newcomer, then you take an hour time. If you are the expert, you are doing, then almost half an hour time will be required for the assembly of the drones. Then the calibration will comes, because this drone you have to be operated with the help of your laptop, with the help of receiving modules, and some kind of the sensor have to be communicate between the devices. So the calibration is one of the very important things. Actually, we have the limited time for this lecture, so I will also show the video of the calibration if the time permit. So generally, there is a 5 reason which for which we will do the calibration is that for the accuracy and to activate the mission planner. Mission planner is one open source software with the help of which you can connect the telemetry and your drone with your laptops. And if you're doing the calibration with the mission planner, your power consumption is also least as compared to your manual operations, and the efficiency will be more. There is no chances. Suppose if you're not a good drone operator, then there is a chances that your drone will be cached down or goes out of your visual range. So in this type of condition, we will always strongly recommend to be calibrate your drones and go for the flight. Calibration, even if you're going for the manual operation, then also the calibration is very, very important things for all of you. So the first things which after this particular assembly you need is the AutoPilot. So basically, it's a AutoPilot is a one open source software. So right now, more than lakhs of the vehicles are using this particular platform. So with the help of this platform, you can control your robots, you can control your drones, and any other type of robotic module you can control. Okay, so first you have to install it on your laptop, and you have to start the mission planner. So this is the first view of the mission planner. Now pointer, with the help of pointer you can find it out. This is the first look over there, in which you can get the flight data, you can plan your flight, you can make your setup, and you can also configure all these type of things. So this is the one look you will find on your laptop when you operate the mission planner. So first thing what you have to do, you have to be calibrate your drones on the mission planner. So you have to be connect your telemetry and with your laptop, and telemetry you have to be start your drones, and drone will be telemetry of both the drone and your laptop will be communicate to each other, and mission planner will be activated. So first thing, there is a disconnected module will be there. So first, as you will connect your telemetry, you have to be put it up, then it will find it out in which particular ports your telemetry is going to be connected, and then automatically it will connect. So before go for calibration, first I think you're all from the IT and CS person, so there is no problem for the download and the setup of the mission planner. So I'm just skipping this particular slide. So with the help of mission planner, we can do these 6 very important things. First is point-to-point click waypoints. Suppose I want to be operate my drones from my home to my office. The distance between my home to office maybe 5 kilometers. So I can give them the point-to-point waypoints. Waypoint means whenever your drone will be start from their starting point to their landing point, they must follow the waypoints. Generally, if you not give the waypoint, there is chances your drone will be confused, because from source to destination, different latitude or longitude condition you will get from the GPS, and some of the times even GPS is not properly customized. So there is a 2 type of things. With the help of this, we can give the waypoints. First, with the help of Google map you can do, and other things you can do. You can give upload the photo. So if you are having the camera, so with the help of photo and processing Raspberry Pi, it can calculate and just find it out the waypoint. Just like us, whenever we are moving, somebody is told after 5 meters you can turn right, and after 2 meters you can turn left. Like this type of things will be there. Then once your mission planner, you have decided the all these points, then what we have to do, we have to be process all this data, and this particular data you have to be transmit, so it will be stored in your some background noise is there. Anyways, so once all these things is there, then software in loop EVI simulator will also be there, so you can simulate your flight and you can run the flight. So basically two basic steps will be there. First thing, you have to be connect the mission planner to the autopilots, and you will get receive their telemetries. Once you have connected your drones over there, you will start getting their telemetries. So with the help of telemetries, you can find it out the exact location of drone. Then you can load the firmware and load the autonomous missions. Generally, baud rate will be required 1,15,200 minimum. If your baud rate will be less than that, then the mission planner will not be work properly. So I always recommend, whenever you will go this type of missions, you will always keep 115 to 00 baud rate. Otherwise, their flight may be on risk. So first, this is the installation of firmware. First, you have to decide which particular device you are doing. You are using right now. I'm focusing on the drone, so I will just decide this particular quadcopter. Then I can take the grid operation. Suppose this is my home location. In home location, I will decide these particular points, and in this all points, your drone will be moved. So suppose I have decided here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this telemetry, I have already telemetry will get this information from the GPS and follow all these points. Okay. Then the landing operation, landing instruction, maybe the go back to home. So after the 40, it is again going back to home and it will be landed. So this is a one very nice feature of the mission planner. Q-board is also available, but Q-board is a little bit complex in operation. So I'm just focusing on mission planner. Now the waypoint detection. Suppose you want to be survey some particular type of areas, okay, and you have mounted the cameras over there. So with the help of that, you will decide the waypoint. So waypoint 1 is automatic, your home location. The waypoint 2 you will decide, and waypoint 3 will be decided. If you just focus on this lower part, the first one is the takeoff. So first one is home location, it will take up, and then you have to decide their latitude. Here you can find it out. The latitude is 35.1331 and longitude is minus 106.331. And at the time of takeoff, you just focus over here. My cursor is visible. My cursor is visible. Okay. So this is the 20 meters. So your drones will be keep up, and with the help of sensor and controller, he will reach to the height of 20 meters. Then waypoint 2, it will goes to the height of 100 meters, and when it will reach to the points, it will goes for the 60 meter, and for the landing, the height reduced to the 0 meters. So in this way, with the help of waypoint, you can operate your drones. So with the help of waypoint also, you can load all these particular programs with the help of your RF module to the controller, and controller will automatically go. So once you have loaded all these programs, there is no need to be intervene all this operation. But in this type of operation, there's a one problem that once your operation will be started, you cannot be interrupted in any of the way. So before operating your drones, you must do these 6 calibrations. First, acceleration calibration, you can check it out, how much acceleration you are getting from your motor. Then for the compass calibration, your direction you can identify. Then the radio communication calibration. So with the help of radio calibration, you can identify whether your drones properly communicate with your laptop or your receiving device. Then the servo output we have to be calibrated. then ESC calibrate, then optional hardware. If you are just mounted Raspberry Pi, then you have to be calibrate. If you are using some kind of the high IR cameras, then it also need to be calibrated. Now there is a one protocol will be there that is known as the Mavlink protocol. So some of the missions, if you don't want to be go as per the mission planner, you want to do something extra on your planning. So with the help of Mavlink protocol, you can divide the waypoint. So it's just like a coding. So with the help of coding, you can write it down the code. So depending on your codes, your drone will be moves. So different type of commands will be there. With the help of that commands, you can navigate your drones from one point to the other points, and you can do different type of operation with the help of drones. All these operations we will discuss separately in the later on. Camera control, you can also go over there, and one other very important thing is the geotagging images with the mission planner. I think you are, if you are already familiar with the drones operation, then you know when you run your drones in the crucial areas, then geotagging is one of the very important things, because what the things is going to be happen sometime your receiver goes out and you're not capable to get it up later. And this thing is not only happening with me and other person, it is happening with everyone. So what we have to do, we are using geofencing and geotagging over here. Generally, swarm drones is also there. You are familiar with the Kumbh Melas. They have used the laser show with the help of drones. So geotagging they will do, and with the help of that, all these type of activities we can conduct. So suppose I will just put it up the geofence around 10 meters. So its meaning is that your drone will not be cross the 10 meters of the areas, because some of the times airport and the building of national importance, you cannot be entered over there. So geotagging is one of the very important things. So geotagging, you can also do the camera geotagging. You need the GPS, and camera mission geotagging may not work properly. So this is one example of the geotagging. So I can geotag that your module will not be go upward, and I will just give the geotag. So your camera will be moving all these type of points. So suppose in some of the operations you don't get the GPS signals properly. So you can also geotag the images. So with the help of cameras, your drones will take the pictures and it will compare it, the previously restored pictures, and it is matched on that particular path it will be followed. So this type of things is also used in many different type of missions. Now mission planner, with the help of in the mission planner, you will find these type of commands: connect, data, plan, setup, configure, simulation, help, and all these type of things will be there. So with the help of mission planner, you can directly connect and collect the real-time data for the different operation, and you can plan your different type of flights. So basically, whenever you connect your drones with the Raspberry Pi and your laptop, you will find these type of modules on your receiving device. Here you can find airspeed. So in your ground laptop, you can find the airspeed of your drones. You can check some kind of the error will be there or not. You can see the head direction, back angle. You can link quality. You can check telemetry link quality. Generally, commercially available drone transmitter is not of good quality. So you always be very clear. Here you can find it out. The number 5 is 22%. So in 22%, if you get the telemetry qualities, that means your signal is going to be deteriorate. So even my suggestion is that if your quality is less than 25%, then you call back your drones immediately. You cannot be go over there. Then the GPS time, altitude, ground speed, battery status, you can also find. Then current flight mode and all these things you can find on your display. So with the help of that, you can identify how exactly your operation will be there. One other important things which I will always recommend to my students is that always use the go back to home command, because many times it's happened because of these are the devices some of the times when we write the codes and when we run all these type of modules, we are not very sure. Some of the times we are writing the code in a different, we are thinking that your PC will understand the code in this way and your system will understand a different way. So I always supposed to be keep the go back to home commands, and I will also give the command that if the battery power is less than 10%, then go back to home. So in this way, you can save your drones. Otherwise, it will be cash it out and you will lose a big amount of money. So with the help of these commands, your drone will be returned back to your homes. Now, we also follow the regulation because drone is one of the very risky things nowadays. And of course, it's a very useful. You can deliver your materials from one point to the other point. And at the same time, you not only use for the commercial, but it's used for the military operation is also required nowadays. So, and even some unsocial elements and the militants is also using the drones. So one regulation policy have been inserted by the Director General of Civil Aviation, DGCA, and there is a two policy they have introduced. In February, they have introduced one policy, and right now they have changed the policies because many drone companies is against of these policies. So now, as per the new regulation, if your drone is less than 250 grams, you can fly anywhere. So these are the categories as per the DGCA, Director General of Civil Aviation, Government of India. So these are the 5 category of the drones. If your drone is 250 grams, there is no issue. You can fly it anywhere because if it is a 250 grams, it even not cover the area more than 500 meters and cannot be get the height of around 20-25 meters. So it's one of the safe, but of course you cannot be operated near to the airports. Then the micros, then small, then medium and large. So these are the 4 categories. For micro, small, medium and large, you need the permission of the DGCA before the flight, and you need some kind of the compliances which you can complete with the help of IoT modules, which we will discuss later on. So presently, the Government of India allow these 5 classes. So whenever you will fly the drone, make sure your drone should be less than 250 grams. Otherwise, you have to be register your drones. You have to get the registered number of your drones, and you have to fulfill certain regulation requirements. So generally, we need the permission from the DGCA, Director General of Civil Aviation. Then you need the you need the security clearance from the Home Affairs, Department of Home, then the Ministry of Defense. You need the permission. You also need the permission of Indian Air Force if you are flying high. You also need the permission of Airport Authority if you are near to the 5 kilometers area. Right now, the Government of India and DGCA also give a map. And according to map, if you are on the green area, then you can operate. If you are on the red zone, you cannot be operate. And if you want to be operate on the red zone, you take the permission from all these. Otherwise, legal department can take the action against you. So generally, this is a possible height as per the DGCA regulations. If you are using the nano, you have to be fly your drones up to the 50 feet only. And if you are having the micros, then you need to only fly 200 feet. Any of the time, it is not allowed to be fly more than this particular length. Otherwise, there is chances with crash. So these are some procedures which we have to be follow during the flight, without which you cannot be do it. First, you have to be learn about the RPS and their registration. First, you have to register your drones. Okay, then after the registration, you have to decide the type of your drones. Then some documents you have to be put it up. Okay, then you have to be registered yourself as an operator. Then you will find UIN. UIN is unique identification number. Okay, this unique UIN is just a unique number for your drones, just like your vehicles. Okay, then you need a UAOP permit before the operation. So once you will get the permit, only in that particular permit you can fly. Then even before pre-flight, you have to submit the information to the local police station 24 hours before, and you have to be upload permission artifact on the RPS, and you should be ready. Then you can ready for the takeoff. During the flight, you have to follow the TRF, temporary flight restriction. You have to be follow, and the post-flight, you also update the flight logs. You have to maintain the log books, and you also use the file occurrence reports. So nano drones, there is no need of any permission, no license, no permit needed. But for the minor drones, you need the permission from the DGCA, and you have to be need a permission of US operational permit 1. Without that, it is not possible for you to work to fly in any of the range. Then for if you're using the medium and the large drone, then you need a US operational permit 2. Okay, so generally I think most of us are academicians, so generally we only need the UAOP drone 1 modules. So in any of the conditions, if you're flying your drones, please, my suggestion is that don't go more than 400 feet, because if you go for more than 400 feet, then it can be interfere with the flight operation. So any of the drones you are flying, never go for the 120 meter of the range over there. One other things is there, important advice for the learner: always keep your drones on your site. It is highly recommended not fly your drones in the dense areas. Okay, always keep it on the ice, keep the very open grounds over there. And second thing, always keep it responsible. Anything is going to be happen, you are responsible for your flight. Okay, so even right now insurance is also issued for your drone flights. So if you are going for the crucial flights, I suggest you also take the insurance for that. Now these are the 6 key applications. Till yet, any questions? Till yet, any questions? Okay, so I'm moving for the core application which we are using the IoT in the drones. The first is the NPNT. So NPNT is indicates the no permission, no takeoff drones. So in the NPNT, there is one kind of the RF modules. This RF module is going to be connected with the internet, and it is connected with the server of the DGCA and air traffic controller, air traffic control. So with that, you have to take the permission from air traffic. So if air traffic controller is not allowed to be fly, okay, then your drone will not operate. Okay, even though you will give the commands, it will not operate. So NPNT is one of the very important device which is right now required to be keep it up in every drones, which is generally in the medium and the large drones. So generally NPNT directly you are going to with the DG Sky platform. DG Sky is the portal of Ministry of Civil Aviation. So Ministry of Civil Aviation site, you have to be connected with the help of mobile or any RF modules, and once you are getting the permission, only then your drone will operate. Then return to home modes. So RTH, return to home, is one of the very important commands. As I have told you, in some of the times you are not very sure in the drone operation. We are not very sure that yes, we have plans, so all these things really goes in this way. So RTH is one of the very important modes. So there is a 4 type of RTH. One is a smart RTH. So this mode allows users to command drones to return to home when tapping on the RTH button. Okay, whenever you are working on it and you will find something goes wrong, you will just put it up the RTH button, drone will be returned back. So basically one RF command is given to the controller, and controller will erase all the previous mode of operation and return back to homes. Then the low battery RTH. If your battery is low and you are supposed to be thinking, your drone controller is supposed to be thinking we follow the given path, and then the battery will be totally sink out. So for the safety precaution, it will be returned back. Then the false save. it's happen when you have the loss of signal. Suppose if you're working on your you're connecting with the telemetry with the help of your laptop goes for the sleep mode, okay, then automatically it will their mission will be compromised. So it will be comes under the fail-safe RTH. So basically RTH is a one kind of the programs which we are running on your controller. So it will it will keep the record of your GPS. It will keep the record of your battery. It will keep the record of your RF module. So any one of these will be compromised. It will give the command, erase all the initial programs and run a specific programs to go back to their home location, which is already decided. Now, other important thing is the obstacle detection. Right now, different type of obstacle. If you're some kind of the obstacle you're getting in front of drones, then what exactly things are going to be happen? The drone may not be collide with the obstacle. It should be goes away. So this type of programming we also do on the drones. So generally, obstacle detecting, what we have to do, we connect one Raspberry Pi with the controller, and with the help of collision detection device. So one ultrasound sensor is mounted over there. So this ultrasound sensor will give us the idea, okay, about the possible obstacle. So once you will get the idea, you can run a different algorithm, and depending on that particular algorithm, you can work over there. Then one other very important application of IoT is the drone detection. So in this drone detection applications, right now a lot of drones is moving from here to there. Anybody can purchase the drone, and with this particular drone, you can put it up some explosive material and you can give it up every year. So right now the security agency is more bothered about the drone detections. So in the drone detection, there's a multiple devices are involved. So we can drone detection, we can use the different modules. But right now, the one very important drone detection modules we'll put it up some kind of the radar or some kind of the very high resolution cameras. So with the help of these very high resolution cameras, you can understand the possible intervene of the drones, and depending on that, you can put it up your anti-drone guns and so on. One other idea to control that control the drone operations is GPS interrupter. So with the help of GPS, you can just GPS blocker, you can just mount it up. So some of the areas, these things we are doing in the buildings of the national importance. GPS signals is blocks over there. And one other things which we'll do, that is known as the GPS snooping. So in GPS snooping, what we have to do, we will give the wrong location, wrong GPS signals. Okay. So with the help of this spoofing, also you can keep the incoming drone into the some other predefined areas. In that particular areas, you can destroy the drones. So IoT is also getting a lot of attention over here, because all these type of either GPS snooping, your high-speed cameras and anti-drone guns, all these guns should be, all these modules should be connected through a one controller, okay, and your communication delay should be minimum, so that you can automatically detect the drone and neutralize it. Because especially most of the drone operations is conducted in the night, so camera is not work. So a lot of research is going on in this particular areas. Then the crowd monitorings, with the help of drones, you can take the picture of the crowd and you can identify nonsense, some specific person on the crowds, and this crowd movement can give the better information about the security agency, and they can betterly control the crowd. Right now, the crowd monitoring and controlling using the drone have been implemented in Kumbh Melas. Okay, so with the help of drones, they can take the pictures of the different places, and with the help of algorithms, they can identify the possible ways to clear the crowds as soon as possible. Then the peripheral security is different type of peripherals. Actually, peripheral security is one of the very important things. So because a lot of research is going on over there. The peripheral security is basically the idea by which with the help of different devices and IoT modules and with the help of different controllers, how you can provide a foolproof security or a area of interest. So we can provide the peripheral security with the help of different means over there. So one book we have one recent book is also, my book is published over here. So if you want to be interested to go and get about the IoT applications in the peripheral security, you can prefer this book. So when we talk about the peripheral security, the first things is RSSI based indoor mapping and the localization. Suppose your drone is moving on the indoor environment. So in indoor environment, you don't have the GPS signal. So how you will work? So with the help of three different transmitter. So RSSI is a received signal strength indicator. So basically received signal strength based modules, your drone will be find it up their own way. But before that, you have to be trained your controller over all these areas. So you have to be move your drone in all possible areas, and then depending on this particular areas, you will get it up different RSSI values, and you have to be store this particular values in your cloud. And with the help of that, with the help of this particular RSSI values, your drone will be or robot will be identify the location. Then the feature-based person detection. Right now, the mask is using. So, if person is wearing the mask, is it possible that we can? Is it possible that we can detect the person? So right now, the what we have to do, we can put it up the one camera modules on the drones, and we will take the pictures, and we will just find it out. We will just scan all the points over there, area of interest, and if the 80% things are going to be matched, we will find it out. So this method is also give us some better results to identify the person, even if he's wearing the mask. So with the help of this particular things, we can also count the person. We can also check whether the person is of our interest, who has entered in this particular areas or not. So these type of things we can do. So here what we have to do, we will start the matching detection, and if it is this person is not matched with our data, we can put it up the alarm. So some of the peripheral security areas where we can restrict the entry of the specific person, then we can only allow some specific person. And right now, all these things, FAMs, and to detect the facial, we are using the CNN over there. Then one other application of IoT is the multiple drone navigation and the formation using the selected target based on the computer vision system. Suppose you want to follow a particular target, okay, with the help of drones, or then your GPS signals is not supporting and problematic. Then all these three drones can be fly in the formation, okay, and they can follow a particular targets. So here we will make one drone as a master and other two drone as a slabs. And depending on the master will get the position data from all these students, and they will communicate to each other, and they will follow a particular object. So these three drones we have used in this setup, and this is the one field test over there. So this is a one small robotic modules, and when this modules is moving, these three drones in a particular formation is flying. Since we don't want any type of collision between the drones, maybe because of malfunctioning, so we you can note it down. We have keep the height of all these three drones on a different altitude. So there is some in this slide you can find how we can calibrate your drones on the mission planners. One video I will show you if the time permit about that. So this is all about from my side. Any questions, or I will start one video about the calibrations.
So how do we manage power constraint of battery in drones?
Sorry.
The battery will have a power constraint. So how do we manage that in drones?
Good. What's your name?
Tuhin Shukla, sir.
Okay. Actually, power, I like this particular question. Not only the power, even the temperature is the biggest hurdle over here. So right now, the many person is working on the hybrid mode. Okay. So they will use a gasoline-based engine. Okay. So gasoline-based engine is connected with one alternator. Alternator is continuously giving the power to the batteries, and battery is giving to the over there. But of course, if you are using the low-cost drones, the power is still the biggest problem. Even you cannot be get it up the flight time more than 25 to 30 minutes.
Okay. So, but this will be a security problem. I am working in IoT security, so this will be a security problem.
Now, what is the security problem? Sorry.
This power drainage will be a security problem.
Actually, only one idea we have for the power saving is that we have to do the flight from the mission planner or Q-board. Okay. Because whenever we go for the mission planner, everything is already fixed. Manually, we will consume more power. Okay. So in mission planner, we already given the waypoints to all the drones. Okay. So it will take a very least power from the telemetry. So they will run more time. Even when we operate the drones from transmitter receiver, it will hardly run for 5 to 10 minutes. When it goes from the telemetry, it is run for the 25 to 30 minutes even.
Okay, sir.
One other question: does the distance between drone information remain same? Yeah. Actually, you know, the real-time operations, many of the times our calculation goes wrong. But that is why, if you remember in my last slide, I have told you that I will keep the altitude of all these three drones is different. But mostly, my suggestion is that you will keep more than a meter of the distance. So it will remain same. In our operations, it is not polite. You have operated drones?
No, sir.
Okay.
So one more question, sir. You said that it's better to keep the drones inside. But what if they have to be sent to some hilly area or remote areas?
Very good questions. Okay, actually, in hilly areas, then I have told you your micro drones will not work. Okay, you need small drones. Okay, because in hilly areas you have to take care some kind of the load, and in that particular type of load, you need a heavy you need a heavy payload. So whenever you take a heavy payload, then it requires more heavy batteries over there. मैं आप लोगों को एक छोटा सा वीडियो शो कर रहा हूँ, एक मिनट, आपको पता पड़ेगा हैवी पेलोड्स वाला कैसा रहता है. आई एम शेयरिंग वन माय स्क्रीन्स. Video is visible?
Yes, sir.
This is a hexa. It's a powerful.
वो होम पे जाएगा, होम पे
So you can find it up. Actually, the system goes for a slip during the flight. Okay, so it will goes again up and go back to their home location. So that is why whenever you go for this particular type of operation, you need a lot of experience, and you always take the precautions. Even I am connected with different drone suppliers. They also told us कि सर कई बार ऐसा होता है कि एक यहाँ निकल गया, कहीं वहाँ निकल गया. If you are going on the swarm drones, I think You're familiar with the SOM operations? So in SOM operation, this type of things is going to be happen, but we should be very careful on all of these type of devices. Of course, IoT is involved over here. We are using telemetry, controller will be there. So with the help of that things, generally I am using the Raspberry Pi. I think some of you is already told they are working on the Raspberry Pi. So Raspberry Pi is a little better to operate as compared to Arduino.
Thank you, sir.
Any other things?
Thank you, sir.
Any other question?
Participants, if you have a question, please unmute yourself and ask, sir.
Otherwise, I wish to show the video for calibration.
Yes, sir, please show that.
Okay.
यार वो तो बढ़िया उसने
Please wait for a minute. Text. तो नहीं कर रहा है इसको डेस्कटॉप जी ड्राइव में करूँ इसको यार ये कुछ चलाने में बहुत टाइम लगेगा इसको फ्लाई कर रहा हूँ तो चल क्यों नहीं दिख नहीं रहा इसमें सेकंड वीडियो चलो इसको जाने दीजिए आपको दिक्कत है एनीवेज हमने डेस्कटॉप पे डाला था कुछ कैलिब्रेशन ओके Please confirm the calibration is properly visible.
So it's moving.
Please confirm the video is visible.
Yes, sir, it's visible.
Yeah, so this is the drone. This drone we are connected with telemetry to our laptop, and we are calibrating it. First, we have to pick it up from the right direction, from the node side. Then we have to keep down. Then left down. Actually, all the four corners we have to do, and I will always recommend it. You have to be keep a one box. So this is the first. After the frame type, we are doing the acceleration calibration. So how much acceleration is going to be happen, we will calibrate. So in the way, the mission planner can be knows the type of different signals you are getting from different positions. Once the calibration is completed, then we go for the compass calibration. In compass calibration, we have to be move your drone in by hand, here to there, so that it can find it out the exact compass values over there. So after that compass verification, we have to do for the motor calibration. So for the motor calibration, we will keep out all the rotors. And then calibrate. So one by one, all the four motors will be calibrated. This is the compass calibration he is doing. Now on all this, you have to move your drones up to these three, 1, 2, 3, and calibration is not going to be completed. So in this way, it can calibrate its compass properly. If you just remember, one telemetry we are connecting with this laptop. Caution. Caution. ड्रोन्स और उसको लेकर आना, ड्रोन और वो रास्पबेरी मॉड्यूल लेकर आना. It's take time generally. Even calibration is also take half an hour times. Now we are connecting the battery for the radio communication. That's verified. So this is the radio communication is going to be checked. Now radio communication is also checked with the telemetry of your manual modules. So here, actually, this is left side. You are accelerate the motors, and the right side you will give the different directions. So whenever you move your this receiver modules, then your calibration is going to be completed. And this calibration you have to do. You have to move all this button till the calibration is not completed. So this particular yellow bar should be completed, and it automatically goes for the next reasons. So you cannot be escape it. Okay, so after the calibration, you will find this type of map. This map is already we have downloaded on our PC. So in this map, it will connect from data from your GPS, and you also have to be validated. Generally, if you are working on the very big structures or the buildings, then it takes a lot of time. Generally, you know, in your mobile, when you open the map, you will get your earliest location, because generally they don't only believe on the GPS location, they're also taking the tower locations, so it's more accurate. But in if you're not using the GPS modules over GSM modules over here, so it will take time, and generally it is taking even 5 to 7 minutes time to locate if your area of operation is covered by over there. Then you have to be set the flight modules, which particular type of flight mode you have to be operate. So this mode you can also finalize over there. So once it is going to be fixed, then you have to be just fix the home location of your drones, and then it can work properly. So this is a small video for your how you can calibrate the drones. So now I also have one physical module with me, so I hope it's visible to all of you. I don't know it's visible to you. So this is the particular drones which we are using for the operations, and we will use the, I think you are familiar with the Raspberry Pi Zero. So this we have put it up for the different type of calibration. So basically when we put it up Raspberry Pi over there, so some kind of operation we can do. It can follow some specific person. Okay, it can take the pictures from the one particular areas. Okay, so a lot of other things he can do. He can pick up the payloads. It can draw the payload. So a lot of things it can do. So this is all about from my side. If anybody have any questions, and my mobile number and mail ID is available. I'm in IIT RAM. So anybody have any doubts, want to perform any type of operation, you're all welcome in my lab. So this is all about from my side. Thank you.
Thank you, sir. Does any participant have more questions?
I think Ramesh Babu have raised the hand, am I? Or it's photo icon.
If I'm asking him to unmute.
So if there is no more question, can we?
I think he's not responding. Okay, sir. Thank you so much for giving your time and valuable knowledge. We hope to have more interactions with you. Thank you so much, sir.
Thank you. Thank you very much.
So we are at end of our today's session. We'll meet again tomorrow at 10 a.m. Thank you all for joining and hope you have filled your attendance sheets. Thank you so much.